So, good afternoon, ma'am.
Good afternoon, sir.
ಸೊ ಇವತ್ತಿನ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಡಾಕ್ಟರ್ ಸೌಮ್ಯ ಮೇಡಮ್ ರವರು ಸಾರಿ ಮ್ಯಾಮ್.
ಪರವಾಗಿಲ್ಲ ಸರ್.
ಸೊ ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. ಇಂದಿನ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಡಾಕ್ಟರ್ ಸೌಮ್ಯ ಕುಮಾರಿ ರವರು ಆರೋಮ್ಯಾಟಿಕ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ಎಂಬ ವಿಷಯದ ಮೇಲೆ ಉಪನ್ಯಾಸ ನೀಡಲಿದ್ದು ಅವರನ್ನು ಅಭೂತಪೂರ್ಣವಾಗಿ ನಮ್ಮ ಅಕಾಡೆಮಿಗೆ ಸ್ವಾಗತಿಸುತ್ತಾ ವೆಲ್ಕಮ್ ಟು ಅಕಾಡೆಮಿ ಮ್ಯಾಮ್.
ಥ್ಯಾಂಕ್ ಯು ಸರ್. ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಸೊ ಅದೇ ರೀತಿ ನಮ್ಮ ಅಕಾಡೆಮಿ ಅಧ್ಯಕ್ಷರಾದಂಥ ಪ್ರೊಫೆಸರ್ ಅಯ್ಯಪ್ಪನ್ ಸರ್ ಹಾಗೂ ಚೀಫ್ ಎಕ್ಸಿಕ್ಯೂಟಿವ್ ಆಫೀಸರ್ ಡಾಕ್ಟರ್ ರಮೇಶ್ ಸರ್ ಅವರನ್ನು ಕೂಡ ಸ್ವಾಗತಿಸುತ್ತಾ ಹಾಗೂ ನನ್ನ ಎಲ್ಲ ಸಹೋದ್ಯೋಗಿಗಳು ಹಾಗೂ ಹಾಜರಾಗಿರುವ ನನ್ನ ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರು ಹಾಗೂ ಎಲ್ಲ ನನ್ನ ಸಹೋದ್ಯೋಗಿಗಳು ಕೂಡ ಸ್ವಾಗತಿಸುತ್ತಾ ಈ ಕಾರ್ಯಕ್ರಮವನ್ನು ನಮ್ಮ ಸೌಮ್ಯ ಕುಮಾರಿ ಅವರಿಗೆ ಬಿಟ್ಕೊಡ್ತಾ ಇದ್ದೀನಿ. ಓವರ್ ಟು ಯು ಮ್ಯಾಮ್.
ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಸೊ ಕಳೆದ ತರಗತಿಯಲ್ಲಿ ತಮ್ಮ ಬಗ್ಗೆ ಒಂದು ಕಿರುಪರಿಚಯ ಮಾಡ್ಕೊಟ್ಟಿರೋದನ್ನ ನಾವು ಪದೇ ಅದನ್ನ
ಬೇಕಾಗಿಲ್ಲ ಸರ್, ಆಲ್ರೆಡಿ ನಾವು ಪರಿಚಯ ಇದ್ದೀವಿ ಸ್ಟೂಡೆಂಟ್ಸ್ಗೆ.
ಸಮಯದ ಅಭಾವ ಕೂಡ ಇರೋದ್ರಿಂದ
ಹೌದು.
ಥ್ಯಾಂಕ್ ಯು. ಓವರ್ ಟು ಮ್ಯಾಮ್.
Thank you, sir. Thank you, sir. Good afternoon, students. As sir told, we have a very less time. So in that less time, how much useful work we can do, let us think about it. Okay. So straight away, I'll get into the topic that is called aromatic hydrocarbons. So I'm very sure all of you belong to first year here, right? You might have already learnt about aromatic hydrocarbons because some of you are writing already your preparatory exams in your colleges, right? Or about to write. So ನಿಮಗೆ ಅದರಿಂದ ಒಂದು ಸ್ವಲ್ಪ ಪರಿಚಯ ಇರುತ್ತೆ. So how like this particular topic is important for you? Maybe ಈಗ ಬರುವಂತ ಮುಂದಿನ ಪರೀಕ್ಷೆಗಿರ್ಬೋದು ಅಥವಾ ನೀವು ನೆಕ್ಸ್ಟ್ ಇಯರ್ ಸೆಕೆಂಡ್ ಇಯರ್ ಅಲ್ಲಿ ಯಾವ್ದಾದ್ರು ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ ತಗೋಬೇಕು ಅಂತಿರ್ಬೋದು. ಆವಾಗ ಈ ಟಾಪಿಕ್ ಅಲ್ಲಿ ನಿಮಗೆ ಯಾವ ತರ ಕ್ವೆಶ್ಚನ್ಸ್ ಬರುತ್ತೆ ಅದ್ರ ಬಗ್ಗೆ ಒಂಚೂರು information I'll be adding here. Okay. So as you know, the topic here we are discussing about hydrocarbons. So when I talk about hydrocarbon, all of you know the compound is consisting of carbon and hydrogen, right? And along with that, we have some term added here that is called aromatic, right? So if you find what is the original meaning of this aromatic, aroma is nothing but something pleasant smelling. Now ಹೇಳ್ಬೋದು ಆ ತರ ಅಂದ್ರೆ ಗ್ರೀಕ್ ವರ್ಡ್ ಡಿರೈವ್ ಮಾಡಿರೋದು aroma is nothing but pleasant smelling. If I take the word here aroma from this, that is nothing but we have here pleasant smelling. So do all this aromatic hydrocarbon having a pleasant smelling? Of course, most of them. So that's how we generalize the thing, ಅಲ್ವಾ? ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೀವು ವೆನಿಲಾ, ಎಲ್ಲರಿಗೂ ಐಸ್ ಕ್ರೀಮ್ ತುಂಬಾ ಫೇವ್ರೇಟ್ ಅಲ್ವಾ? ವೆನಿಲಾ ಐಸ್ ಕ್ರೀಮ್ ಅಲ್ಲಿ ನಾವು ಹೇಳ್ತೀವಿ ವೆನಿಲಾ ಫ್ಲೇವರ್ ಅಂತ ಅಂತೀವಿ, ರೈಟ್? ವೆನಿಲಾ ಫ್ಲೇವರ್ ಎಲ್ಲಿಂದ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ತೀವಿ? ವೆನಿಲಾ ಬೀನ್ಸ್ ಇಂದ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ತೀವಿ. If you look at the structure of that vanillin, what you extract from the vanilla beans, it has a benzene structure. So ನಿಮಗೆ benzene ಪರಿಚಯ ಇರಬಹುದು. So here we have a ring. This is nothing but we call it as benzene ring. ಈ benzene ring ಅಲ್ಲಿ we have a aldehyde group attached, we have a methoxy group attached over here, and we have a hydroxy group attached over here. This is nothing but we call it as vanillin. ಒಂದು ಪರಿಚಯ ಅಷ್ಟೇ. ಯಾಕಂದ್ರೆ ಅರೋಮಾ ಅನ್ನೋ ವರ್ಡ್ ಯಾಕೆ ಬಂತು ಅಂತ ಕೇಳಿದ್ರೆ ಈ ವೆನಿಲಿನ್ ನಾವು ಸ್ಟ್ರಕ್ಚರ್ ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ ನಮ್ಗೆ ಇಲ್ಲಿ. ಓಕೆ, ಈ ವೆನಿಲಿನ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದ ವೆನಿಲಾ ಬೀನ್ಸ್ ವಿಚ್ ಹ್ಯಾಸ್ ಎ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ ಫ್ಲೇವರ್. ಓಕೆ, ಸೊ ಸಿಮಿಲರ್ಲಿ ಈಗ ಬೆನ್ಸಾಲ್ಡಿಹೈಡ್ ಆಗಿರ್ಬೋದು. ನಾವು ಬೆನ್ಸಾಲ್ಡಿಹೈಡ್ ಬಗ್ಗೆ ಮಾತಾಡ್ಬೇಕಾದ್ರೆ ಹೇಳ್ತೀವಿ ನಾವು ಬಿಟರ್ ಆಲ್ಮಂಡ್ ಅಂತ. ಓಕೆ, ಸೊ ಹಾಗೆ ಪ್ರತಿಯೊಂದು ಅರೋಮ್ಯಾಟಿಕ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ಮೋಸ್ಟ್ ಆಫ್ ದಮ್ ಜನರಲಿ ಅವಕ್ಕೊಂದು ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ ಪ್ಲೆಸೆಂಟ್ ಸ್ಮೆಲ್ ಇರುತ್ತವೆ. ಓಕೆ, ಸೊ ಹಾಗಾಗಿ ಇಂಥ ವರ್ಡ್ ನ ನಾವು ಅರೋಮ್ಯಾಟಿಕ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ ಅರೋಮಾ ಅನ್ನೋ ವರ್ಡ್ ನ ಇಲ್ಲಿ ಯೂಸ್ ಮಾಡಿದೀವಿ. ಸೊ ಈಗ ಹಾಗಂತ ಹೇಳಿದ್ರೆ ಎಲ್ಲದಕ್ಕೂ ಪ್ಲೆಸೆಂಟ್ ಸ್ಮೆಲ್ ಇದೆಯಾ ಅಂತ ಕೇಳಿದ್ರೆ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಮಾರ್ಕ್ ಇದೆ, ಇಲ್ದೆ ಇರ್ಬೋದು. ಬಟ್ ಈಗ ಓವರ್ ಎ ಪೀರಿಯಡ್ ಒಂದಷ್ಟು ಕಾಂಪೌಂಡ್ಸ್ ನ ಅವರು ತಗೊಂಡು ವೆನ್ ದೇ ಟ್ರೈ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ದಟ್ ದೇ ಫೌಂಡ್ ದಟ್ ಮೋಸ್ಟ್ ಆಫ್ ದಮ್ ಆರ್ ಹ್ಯಾವಿಂಗ್ ದ ಪ್ಲೆಸೆಂಟ್ ಸ್ಮೆಲ್ಲಿಂಗ್. ಅಲಾಂಗ್ ವಿತ್ ದಟ್ ದೇ ಫೌಂಡ್ ಒನ್ ಯುನೀಕ್ ಪ್ರಾಪರ್ಟಿ ಇಸ್ ಲೈಕ್ most of these hydrocarbons, aromatic hydrocarbons, they had a structure that is nothing but they are having a compound like benzene or its derivatives. ಓಕೆ, ಹಾಗಾಗಿ aromatic hydrocarbons ನ ನಾವು ಅರೀನ್ಸ್ ಅಂತಾನು ಕರಿತೀವಿ. ಇನ್ ಶಾರ್ಟ್ ವಿ ಕಾಲ್ ದಮ್ ಆಸ್ ಅರೀನ್ಸ್. ಬೇಸಿಕಲಿ ಹಿಯರ್ your benzene will become benzene is ಪೇರೆಂಟ್ aromatic hydrocarbon ಅಂತ ಕರಿತೀವಿ ನಾವಿದ್ನ. ಯಾಕಂದ್ರೆ ಮೋಸ್ಟ್ ಆಫ್ ದ aromatic hydrocarbons ಅಲ್ಲಿ ಬೆನ್ಝೀನ್ ಒಂದು ರಿಂಗ್ ಪ್ರೆಸೆಂಟ್ ಇದ್ದೇ ಇರುತ್ತೆ ಜನರಲಿ ಒಂದು ಕ್ಲಾಸ್ ಆಫ್ aromatic hydrocarbons ಅಲ್ಲಿ. ಓಕೆ, ಸೊ ಲೆಟ್ us look into it. What is this benzene? It is very important because aromatic hydrocarbon, your studies will be in and around benzene and its derivatives. So what is that benzene? All of you know the structure of benzene, and molecular formula is what? Benzene has a molecular formula of C6H6. You know the story of this also. ಈ ಬೆನ್ಝೀನ್ ರಿಂಗಿಗೆ ಒಂದು ಸ್ಟ್ರಕ್ಚರ್, ಬೆನ್ಝೀನ್ ಅನ್ನೋ ಕಾಂಪೌಂಡ್ ನ ಅವ್ರು ಸ್ಟ್ರಕ್ಚರಲ್ ಎಲಿಸಿಡೇಷನ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ತುಂಬಾನೇ ಕಷ್ಟಪಟ್ರು. C6H6 ಅಂತ ತಗೊಂಡಾಗ ನಮ್ಗೆ ಏನಾಗುತ್ತೆ? ಇಟ್ ವೋಂಟ್ ಬಿಲಾಂಗ್ ಟು ಆಲ್ಕೇನ್ಸ್ ಬಿಕಾಸ್ ಯು ನೋ ದ ಜನರಲ್ ಫಾರ್ಮುಲಾ ಇಸ್ CnH2n+2. ಆಲ್ಕೀನ್ಸ್ ತಗೊಂಡ್ರೆ CnH2n ಬರುತ್ತೆ, ಆಲ್ಕೈನ್ಸ್ ತಗೊಂಡ್ರೆ CnH2n-2 ಬರುತ್ತೆ. ಅದು ಯಾವುದಕ್ಕೂ ಇದು ಅಪ್ಲೈ ಆಗಲ್ಲ. ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ನೀದರ್ ಅನ್ ಆಲ್ಕೇನ್ ನಾರ್ ಅನ್ ಆಲ್ಕೀನ್, ನಾಟ್ ಇವನ್ ಬಿಲಾಂಗ್ ಟು ಆಲ್ಕೈನ್. ಒಂದು ಸಪರೇಟ್ ಸಿಸ್ಟಮ್. ಆಗ ಇದ್ರ ಸ್ಟ್ರಕ್ಚರ್ ನ ಹೇಗಪ್ಪ ಬರೆಯೋದು? ಯಾಕಂದ್ರೆ ನಿಮಗೆ ಗೊತ್ತು ಕಾರ್ಬನ್ ಇಸ್ ಟೆಟ್ರಾವ್ಯಾಲೆಂಟ್. ಕಾರ್ಬನ್ಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಎಷ್ಟು ವ್ಯಾಲೆನ್ಸಿ ಬರುತ್ತೆ? 4. ಸೊ ಹಾಗಾಗಿ ಸ್ಟ್ರಕ್ಚರ್ ಡಿರೈವ್ ಮಾಡ್ತಾ ಹೋದ್ರೆ ಇದಕ್ಕೆ ಸ್ಟ್ರಕ್ಚರ್ ಇನಿಷಿಯಲಿ ಅವ್ರು ತುಂಬಾ ಕಷ್ಟಪಟ್ರು. ದೆನ್ ಯು ವಿಲ್ ಬಿ ನೋಯಿಂಗ್ ದ ಸೈಂಟಿಸ್ಟ್ ನೇಮ್, ದಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಕೆಕ್ಯುಲೆ, ಆಗಸ್ಟ್ ಕೆಕ್ಯುಲೆ ಅಂತ. ಅವ್ರಿಗೆ ಆಕ್ಚುಲಿ ಹಿ ಡ್ರೆಮ್ಟ್ ಅಬೌಟ್ ದ ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ಬೆನ್ಝೀನ್. ನಿಮ್ಗೆ ಕೇಳಿಸ್ಕೊಂಡಿರ್ಬೋದು ನಿಮ್ ಟೀಚರ್ಸ್ ಕಡೆಯಿಂದ. ಅವ್ರಿಗೆ ಒಂದಿನ ಕನ್ಸಲ್ಲಿ ಒಂದು ಹಾವು ಅದ್ರದ್ದು ತಲೆನ ಅದೇ ಬಾಲನ ಅದೇ ಕಚ್ಕೊಂಡಂಗೆ ಕನ್ಸ್ ಬಿತ್ತಂತೆ. ಸೊ ಫ್ರಮ್ ದೇರ್ ಹಿ ಟುಕ್ ದ ಐಡಿಯಾ ಅಂಡ್ ಡಿರೈವ್ಡ್ ದ ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ಬೆನ್ಝೀನ್. ಈ 6 ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಇನ್ ದ ಬೆನ್ಝೀನ್ ದೇ ಆರ್ ಕನೆಕ್ಟೆಡ್ ಟು ಒನ್ ಅನದರ್. ಈ ತರ ಓಕೆ, ಸೈಕ್ಲಿಕ್ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ. ಅಂದ್ರೆ ಈಗ ನಾನು ಯಾವುದೋ ಒಂದು ಕಾರ್ಬನ್ ನ ಇದು ಹೆಡ್ ಆಫ್ ದ ಸ್ನೇಕ್ ಅಂತ ತಗೊಂಡ್ರೆ another carbon will be the tail of that snake. He dreamt it like the snake is biting its own tail. So that how he could able to give the structure for the benzene. So these are like linked to one another like this, and 6 hydrogens are attached to the carbon in this way. So you know the carbon valency is 4, so it is not completely satisfied. Then we have, there are set of 3 pi bonds in an alternate way. So if you count in this, or if you recall from your chemical bonding the hybridization concept, you can see here carbon in this case, all the carbons, not only one carbon, all the carbons are sp2 hybridized, and we have an alternate single and double bond. So totally in benzene ring, this is also one of the important question for you. In benzene ring we will find 1, 2, 3, 4, 5, 6 and CH. So here we have 6 C2C sigma bond is present, and there are 6 C2 hydrogen, carbon to hydrogen sigma bonds are present, and we can find 3 carbon to carbon pi bond, right? So this is what pi bond here. So this is how we can see the structure of benzene ring. Okay, and one important point about the benzene ring is this pi bond is delocalized. We call these electrons, what I have written as a double bond, or what we call it as a pi bond. That electron is delocalized. It is not between these two, it can be between these two. That's how further the stability of benzene ring you could able to explain with the help of resonance. Either the double bonds in this way, or the double bonds can be put in the other way, alternate way, or we can write the equivalent structure here in terms of a ring in between the benzene ring. That ring shows that the electrons here, pi electrons, are delocalized. Okay, so this is the story of benzene, because structure to be known. ಒಂದೊಂದ್ಸತಿ 1 mark question ಕೇಳ್ತಾರೆ, ಎಷ್ಟು ಸಿಗ್ಮಾ ಬಾಂಡ್ ಎಷ್ಟು ಪೈ ಬಾಂಡ್ ಇದೆ? ಪೈ ಬಾಂಡ್ ಇರೋದು 3, ಸಿಗ್ಮಾ ಬಾಂಡ್ put together 6 plus 6 you have the 12 sigma bonds. Okay, ಈಗ ಇದು ಆಸ್ ಎ ಪೇರೆಂಟ್ ನಾವು ಬೆನ್ಝೀನ್ ಅಂತ ಅರ್ಥ ಮಾಡ್ಕೋತೀವಿ. ಬೆನ್ಝೀನಿಗೆ ಕ್ಯಾನ್ ಐ ಪುಟ್ ಸಮ್ ಅದರ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್? ಎಸ್, ಆಫ್ ಕೋರ್ಸ್ ವಿ ಕ್ಯಾನ್ ಹ್ಯಾವ್ ಲಾಟ್ ಆಫ್ ಡಿರೈವೇಟಿವ್ಸ್ ಆಫ್ ಬೆನ್ಝೀನ್. ದೇ ಆರ್ ಆಲ್ ಕಾಲ್ಡ್ ಆಸ್ ಅರೋಮ್ಯಾಟಿಕ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್. ಹಾಗಂದ್ರೆ ಬೆನ್ಝೀನ್ ರಿಂಗ್ ಇಲ್ಲದೆ ಇದ್ರೆ ಅರೋಮ್ಯಾಟಿಕ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ ಆಗೋದೇ ಇಲ್ವಾ ಅಂತ ನೀವು ಕ್ವಶನ್ ಕೇಳಿದ್ರೆ ಖಂಡಿತ ಸಾಧ್ಯ ಇದೆ. ದೇರ್ ಆರ್ ಸೆಟ್ ಆಫ್ ಕಾಂಪೌಂಡ್ಸ್ ಬೆನ್ಝೀನ್ ರಿಂಗ್ ಇಲ್ಲದೆ ಇದ್ರೂ ಅರೋಮ್ಯಾಟಿಕ್ ಆಗಿರ್ತವೆ. ಅಂತದನ್ನ ನಾವು ನಾನ್ ಬೆನ್ಝಿನಾಯ್ಡ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಅದ್ರ ಜೊತೆಗೆ ನಾವು ಹಿಟ್ರೋಸೈಕ್ಲಿಕ್ ಅರೋಮ್ಯಾಟಿಕ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ಬರ್ತವೆ ನಮಗೆ. ಓಕೆ, ಸೊ ಅರೋಮ್ಯಾಟಿಕ್ ಕಾಂಪೌಂಡ್ಸ್ ಬರ್ತವೆ ಹಿಟ್ರೋಸೈಕ್ಲಿಕ್ ಅಂದ್ರೆ ಅದರ್ ದನ್ ಕಾರ್ಬನ್ ಇರ್ಬೋದು. ಸೊ ದರ್ ಆರ್ ವೆರೈಟೀಸ್, ನಾಟ್ ಓನ್ಲಿ ಬೆನ್ಝೀನ್ ಅಂಡ್ ಡಿರೈವೇಟಿವ್ಸ್ ಆರ್ ನೋನ್ ಆಸ್ aromatic, even non-benzenoids are also there. But if I want to understand whether a given compound is aromatic or not, is there only one way? ಮ್ಯಾಮ್ ನೀವೇನೋ ಪ್ಲೆಸೆಂಟ್ ಸ್ಮೆಲ್ ಇರ್ತವೆ ಹಾಗಂತ ಪ್ಲೆಸೆಂಟ್ ಸ್ಮೆಲ್ ಇರೋದೆಲ್ಲ ಅರೋಮ್ಯಾಟಿಕ್ ಅಂತ ಕ್ವಶನ್ ಕೇಳಿದ್ರೆ may not be correct, right? So adonde criteria alla. So scientists wanted to understand what is that something special about the aromatic hydrocarbons. Then they tried understanding it in terms of a property called aromaticity. So ಯಾಕೆ ಆ ಟರ್ಮ್ ಬಂತು ಅಂತಂದ್ರೆ, ಈಗ ಬೆನ್ಝೀನ್ ನೋಡಿದ್ರೆ ನಿಮಗೆ ಇಲ್ಲಿ ಕಾಣಿಸ್ತಿರ್ಬೋದು ಸ್ಟ್ರಕ್ಚರ್ ಅಲ್ಲಿ ಡಬಲ್ ಬಾಂಡ್ ಇದೆ ಅಲ್ವಾ, ಆಲ್ಟರ್ನೇಟ್ ಡಬಲ್ ಬಾಂಡ್ ಇದೆ. ಸೊ ಹಾಗಂತ ಆಲ್ಕೀನ್ ರಿಯಾಕ್ಷನ್ಸ್ ನ ಇದು ತೋರಿಸುತ್ತಾ ಅಂತ ಕೇಳಿದ್ರೆ ನಿಮಗೆ ಆಲ್ಕೀನ್ ರಿಯಾಕ್ಷನ್ ಫೆಮಿಲಿಯರ್ ಇರ್ಬೋದು. ಇಫ್ ಯು ಟೇಕ್ ಬ್ರೋಮಿನ್ ಇನ್ CCl4 ಆಲ್ಕೀನ್ ಹಾಕಿದ್ರೆ ಡಿಕಲರೈಸೇಷನ್ ಆಫ್ ಬ್ರೋಮಿನ್ ಸೊಲ್ಯೂಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ದಟ್ ಇಸ್ ಅ ಟೆಸ್ಟ್ ಫಾರ್ ಅನ್ಸ್ಯಾಚುರೇಷನ್ ಅಂತ. ಹಾಗಂತ ಇದನ್ನ ತಗೊಂಡು ಇಫ್ ಐ ಟೆಸ್ಟ್ ಇಟ್ ವಿತ್ ಬ್ರೋಮಿನ್ ಆ ಸೊಲ್ಯೂಷನ್ ಅಂದ್ರೆ ಖಂಡಿತ ಅದು ರಿಯಾಕ್ಟ್ ಮಾಡಲ್ಲ. ಇಲ್ಲಿ ಡಬಲ್ ಬಾಂಡ್ಸ್ ಇದ್ರೂನು ಆಲ್ಕೀನ್ಸ್ ನ ಯಾವುದೇ ರಿಯಾಕ್ಷನ್ ನ ಇದು ತೋರಿಸಲ್ಲ. ಓಕೆ, ಯಾಕೆ ಅಂತಂದಾಗ ನಾವೇನ್ ಹೇಳ್ತೀವಿ, ಇಟ್ ಇಸ್ ಎ ರೆಸೊನೆನ್ಸ್ ಸ್ಟೆಬಿಲೈಸ್ಡ್ ಸ್ಟ್ರಕ್ಚರ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಆರೋಮ್ಯಾಟಿಕ್ ಅಂತೀವಿ, ದಟ್ ಇಸ್ ಅ ಸ್ಪೆಷಲ್ ಪ್ರಾಪರ್ಟಿ ಅಂತೀವಿ. ವಾಟ್ ಇಸ್ ದಟ್ ಸ್ಪೆಷಲ್ ಪ್ರಾಪರ್ಟಿ ಇಸ್ ನೋನ್ ಆಸ್, ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ aromaticity. So now we will take a few minutes to understand what is aromaticity. By understanding that aromaticity, when I give an example or when I see a compound, can I try to understand whether it is aromatic or not? Yes, of course. Okay, so you should be in a position to identify whether the given compound is aromatic or not. So let us move into a property called aromaticity here. Okay, yes, what are the characteristic of aromatic compound, aromaticity? How do we decide this? The first criteria is planarity. Okay, so the compound here should be planar. Second thing should be, it should have a delocalized pi electron system. Okay, delocalized pi electrons in ring. Okay, so that means you can understand the compound should be cyclic. Okay, in ring. Third one, it should satisfy Haeckel rule. Okay, Haeckel rule of aromaticity anta heltivi. Haeckel rule of aromaticity. What is that Haeckel rule of aromaticity? It should satisfy 4n plus 2 pi electron rule. Okay, 4n plus 2 pi electron rule. What is this n here? N is nothing but integer. Its value can be 0, 1, 2, etc. ಅಂದ್ರೆ how do we understand? In case if I substitute n value 0, ಇಲ್ಲೇನಾಗುತ್ತೆ 4 into 0 plus 2 ಅಂತಂದ್ರೆ it has 2 pi electrons. Okay, or if I substitute n is equal to 1, it will be 4 into 1 plus 2 ಅಂದ್ರೆ it has 6 pi electrons. ಅದೇ ತರ n is equal to 2 ಹಾಕಿದ್ರೆ it will have 10 pi electrons. ಅಂದ್ರೆ I am talking about here, if I have a compound given for me, by looking at its structure, can I understand structure is cyclic ring? Okay, it is easy to understand because you should have a closed loop. All of you know what is the meaning of ring. And then it should be planar. That means all the atoms you should find in one plane. Generally we decide it with the help of hybridization, right? And then it should satisfy this 4n plus 2 pi electron rule. And then number of pi electrons should be either 2 pi electrons. Okay, because one pi bond has 2 electrons, you know that. So 2 pi electrons ಇರಬೇಕು ಅಥವಾ 6 pi electrons ಇರಬಹುದು ಅಥವಾ 10 pi ಅಂದ್ರೆ 1 pi bond ಅಥವಾ 3 pi bond ಇರಬಹುದು ಅಥವಾ 5 pi bond ಇರಬಹುದು. ಆಗ we will take this system as aromatic. ಈಗ let us take up some examples and understand. Okay, so the first example I'll work out here, your benzene itself, because you know it already, it is aromatic, right? But shall we check whether the conditions are satisfied? Look at the carbons here. Okay, these are the 6 carbons, right? And we know all of them are sp2 hybridized, so you have a planar ring here. Okay, yes, it is having a ring and the ring is planar because all of them are sp2 hybridized. And how many pi electrons are there here? 3 pi bonds are there. 3 pi bonds. That means 6 pi electron. Each pi bond has 2 electrons. 6 pi electron. Yes, that means I have 4n plus 2 pi electron rule satisfied by applying n is equal to 1. Yes, so the system is aromatic. Correct? Yes. Now let us take the next example here. I will take two benzene rings together like this. Okay. You might have seen this ring already. Here you have to put alternate. So this is nothing but naphthalene. Naphthalene balls ellaru kelirboda. Okay. So in toilets and all we will use that naphthalene smelling compound. It has a characteristic pleasant smelling, right? Naphthalene balls anta kelirtira. Correct? So this is the structure of naphthalene. Now let us see carbons. You know, all the carbons here are having the pi bond means, yes, it is a ring system and all of them are having the double bond. That means they are sp2 hybridized and the system is planar. Correct? And ಎಷ್ಟು pi bond ಇದೆ? 1, 2, 3, 4, 5. So we have 5 pi bonds. 5 pi bonds means how many electrons? 10 pi electrons. 10 pi electrons ಇದೆಯಾ ನಮ್ಮ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ? Yes. That means we have 4n plus 2 pi electron rule ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? N value will be equal to 2. Yes, it satisfies the Huckel rule. That means the system is aromatic. Correct? Yes. ಇನ್ನೊಂದು ತಗೊಳ್ಳೋಣ example ಇಲ್ಲಿ. So let me have 3 of the benzene rings here fused like this we will take. Okay. So alternate we have here double bond. Then one more I can fuse it here. I will have this. Look at the carbons, all these carbons, double bond. Here also it is sharing a double bond, that is pi bond, pi bond, pi bond, pi bond, right? So again, this is also cyclic ring we have, right? And all are sp2 hybridized, because when you know how to decide the sp2 hybridization, carbon having a like a pi bond or a double bond between the two carbons, that carbon will be sp2 hybridized. So if you check, entire system is having sp2 hybridized carbons here, right? So what we can say, this is planar. And how many pi bonds we have? 1, 2, 3, 4, 5, 6, 7. 7 pi bonds are present in this. That means 14 pi electrons. That means again this is also satisfying. Here n value will be equal to how much? So we have 3, n value will be 3. So this is also aromatic. Okay. So you may be wondering, ma'am is taking the similar example. Benzene ಇದೆ, ಆಮೇಲೆ ಇನ್ನೊಂದು benzene ring ಹಾಕಿದ್ರು, ಆಮೇಲೆ ಇನ್ನೊಂದು benzene ring ಹಾಕಿದ್ರು ಅಂತ ಯೋಚನೆ ಮಾಡ್ಬೋದು. ಈ ತರ ಇಲ್ಲದೆ ಇದ್ರೆ ಅವಾಗ ಏನ್ ಮಾಡೋದು? ಈ ತರ ಇದ್ರೆ ಈಸಿ ಮ್ಯಾಮ್, ಬಿಕಾಸ್ ಬೆನ್ಸಿನ್ ರಿಂಗ್ ಇದೆ, ಹಾಗಾಗಿ ನಾವು ಈಸಿಯಾಗಿ ಐಡೆಂಟಿಫೈ ಮಾಡ್ಬೋದು ಅದು ಅರೋಮ್ಯಾಟಿಕ್ ಅಂತ. ಅದು ಇಲ್ಲದೆ ಇದ್ರೆ ಏನ್ ಮಾಡೋದು ಅಂತ. So let us take few more. So these are very important criterias for the aromaticity. Planar ಇರಬೇಕು structure, and you should have a delocalized pi electron system, ಅಂದ್ರೆ uninterrupted pi electron cloud ಇರಬೇಕು, and it should satisfy the Huckel rule. Okay, so that is the criteria. Keep in your mind. Okay, now I'll take some more examples here. Okay, fourth one, look at it. I'll take a cyclopropene. You are aware of cyclopropene. Propene andre eno? You know, C3H6 we have, right? So here cyclopropene, just I'm introducing like cyclopropene andre eno anta. So we have a cyclopropenyl cation tagotini. This carbon is carrying a positive charge. So you have cyclopropenyl cation. So now you don't find here the benzene ring. Can we check whether it is aromatic? Yes, of course. Look at the carbons here. This carbon and this carbon sharing the pi bond. So this is sp2 hybridized. This carbon, definitely this is also sp2, because in your basics of first chapter organic chemistry you have learned hybridization of carbocation alva. Carbocation ಏನ್ hybridization ಇರುತ್ತೆ? sp2. Okay, so ಇದು sp2 ಇರೋದ್ರಿಂದ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? empty p orbital ಇರುತ್ತೆ. So ಈಗ ಸ್ಟ್ರಕ್ಚರ್ ನ ನಾನು ಈ ತರ ಬರೆದ್ರೆ ಇಲ್ಲಿ, okay, this is having positive charge. Here you have the empty, this is empty p orbital. ಮರ್ತ್ ಹೋಗಿದ್ರೆ ಫಸ್ಟ್ ಚಾಪ್ಟರ್ ನ ತೆಗೆದು ನೋಡಿ, ಅಲ್ಲಿ ಸ್ಟ್ರಕ್ಚರ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಎಂಟಿ ಪಿ ಆರ್ಬಿಟಲ್ ಇರುತ್ತೆ ಕಾರ್ಬೋಕ್ಯಾಟಯಾನ್ ಅಲ್ಲಿ. ಇಲ್ಲಿ ಡಬಲ್ ಬಾಂಡ್ ಇರುತ್ತೆ ಅಲ್ವಾ? ಸೊ ಇಲ್ಲಿ ನಮಗೆ ವಿ ಹ್ಯಾವ್ ಎ ಆರ್ಬಿಟಲ್ ಈ ತರ ಇರುತ್ತೆ ಸ್ಟ್ರಕ್ಚರ್. ಇಲ್ಲಿ ನಿಮಗೆ ಬರ್ದಾಗ ಸ್ವಲ್ಪ ಅದನ್ನ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ತೋರ್ಸಕ್ ಕಷ್ಟ ಆಗ್ಬೋದು 2 dimensional ಅಲ್ಲಿ, ಬಟ್ ಲೆಟ್ ಮಿ ಟ್ರೈ. ಸೊ ಯು ಕ್ಯಾನ್ ಹ್ಯಾವ್ ಹಿಯರ್ ದ ಪೈ ಆರ್ಬಿಟಲ್ಸ್ ಲೈಕ್ ದಿಸ್. ಸೊ ದೀಸ್ ಆರ್ ಹ್ಯಾವಿಂಗ್ 1 electron each. ಈ ತರ ಆರ್ಬಿಟಲ್ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಇರುತ್ತೆ. ಸೊ ದಿಸ್ ಆರ್ಬಿಟಲ್ ವೆನ್ ಐ ಹೋಲ್ಡ್ ಇಟ್ ಪ್ಲೇನಾರ್ ಈ ತರ ಮಾಡಿದಾಗ ದಿಸ್ ಆರ್ಬಿಟಲ್ ಕ್ಯಾನ್ ಓವರ್ಲ್ಯಾಪ್ ವಿತ್ ದಿಸ್ ಆಲ್ಸೋ. ಓಕೆ, ಸೊ ಏನಾಗುತ್ತೆ, electrons will be delocalized ಇಲ್ಲಿ. Okay, so I'll show that in this place only. This is empty p orbital. So this electron, I can shift this electron between these 2 carbon and write the structure like this. Look at the structure. Now this gets a positive charge. Okay, or we can write one more structure here. I can shift the bond this side and write a positive charge here. That means your pi electron is delocalized. So first system, yeah, ring or cyclic system it is. Of course it is a ring. All are sp2 hybridized, so it is a planar structure. No doubt it is in a single plane we have. And then how many pi electrons? 1 pi bond. That means 2 pi electrons. That means we have 4n plus 2 pi electron rule, where n is equal to 0. Satisfied. So this is also aromatic. Okay, this is a not a benzene ring, but still it is aromatic because the properties, what are the expected characteristics we have according to the aromaticity, it can be shown by this compound. So I can call it as aromatic. Now let me take up the next example here. So competitive exam, they will be having the similar questions. They will ask among the following one which is aromatic. 4 choice irutte, ನೀವು aromatic ಯಾವುದು ಅಂತ ಗುರುತಿಸಬೇಕು. ಅಥವಾ they may ask one which is not an aromatic compound, so ಅದನ್ನು ಮಾಡಬಹುದು. So ಇಲ್ಲಿ next example I'll take this. Okay, 5 corners you have. So cyclopentane, we have pentadienyl, I have an anion. So this is called cyclopentadienyl anion. So in this case, if I look at the pi bonds, yes, now first sp2 hybridized, idu sp2, idu sp2, idu sp2. Illi anion, so that is also sp2. When anion, we have carbanion in the ring, it will be definitely sp2 hybridized. So your ring system or cyclic system is satisfied, planarity is satisfied. Now I need to check on how many pi electrons are there. ನೋಡಿದ್ರೆ 2 pi bond ಕಾಣಿಸುತ್ತೆ. ಆದ್ರೆ ಈ ಕೇಸಲ್ಲಿ these electrons which are present in this carbon, these electrons are delocalized. So ಇಲ್ಲಿ ನಾನು ಏನ್ ಬರಿಬಹುದು ಅಂದ್ರೆ ಇದನ್ನ ಇಲ್ಲಿಗೆ ಶಿಫ್ಟ್ ಮಾಡಬಹುದು. ರೆಸೊನೆನ್ಸ್, ಡಿಲೋಕಲೈಸೇಷನ್, ಬೆನ್ಝೀನ್ ಅಲ್ಲಿ ನೀವು ಅರ್ಥ ಮಾಡ್ಕೊಂಡಿರ್ತೀರ ಅದನ್ನ. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ಬರುತ್ತೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್, ಡಬಲ್ ಬಾಂಡ್ ಇಲ್ಲಿ ಬರುತ್ತೆ. ಸೊ ಲೈಕ್ ದಿಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ಯಾನ್ ಡಿಲೋಕಲೈಸ್ ಇನ್ ಟು ದ ಅದರ್ ಕಾರ್ಬನ್ ಲೈಕ್ ದಿಸ್. ಅಂದ್ರೆ ಈ 2 ಎಲೆಕ್ಟ್ರಾನ್ ಏನ್ ಕಾರ್ಬನ್ ಅಲ್ಲಿ ಇದೆಯೋ ದಟ್ ಈಸ್ ಆಲ್ಸೋ ಇನ್ವಾಲ್ವ್ಡ್ ಇನ್ ಡಿಲೋಕಲೈಸೇಷನ್. ಓಕೆ, ಸೊ ಪುಟ್ ಟುಗೆದರ್ ಎಷ್ಟಾಗುತ್ತೆ, ಇದನ್ನ ಡಿಲೋಕಲೈಸ್ ಮಾಡಿದ್ರೆ ನಾನು 6 pi electrons ಬರುತ್ತೆ. So your compound is aromatic. Okay, now I'll give another example. Same compound I'll take here, double bonds, but this carbon I'll convert into positive charge. This is called cyclopenta, okay, dienyl cation. ಈಗ ringo, yes, it is a ring system. Okay, and it is planar also. This is also sp2, these 4 also sp2, so planar. But how many pi electrons are there? 2 pi bonds, 2 pi bonds. So you have 4 pi electrons. 4 pi electron ಬಂದ್ರೆ ನಮಗೆ aromatic ಆಗುತ್ತಾ? ಇಲ್ಲ. So 4 pi, 4n plus 2 pi electron rule ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? Electron rule ಅಲ್ಲಿ n is equal to 0 ಅಂದ್ರೆ 2 pi ಬರಬೇಕು, n is equal to 1 ಅಂದ್ರೆ 6 pi ಬರಬೇಕು, n is equal to 3 ಅಂದ್ರೆ ಇಲ್ಲಿ we have 4 3s are 12 plus 2 14 ಬರುತ್ತೆ ಅಲ್ವಾ? So ಹಾಗಾಗಿ 4 pi electrons, it is not satisfying the Huckel rule. 4n plus 2 pi electron rule ನ satisfy ಮಾಡಿಲ್ಲ. So this system is called non-aromatic. ಕಾಣಿಸ್ತಾ ಇದೆ ಅಲ್ವಾ ಬೋರ್ಡು? So this is called non-aromatic. So if my system is cyclic ring with planar and satisfying 4n plus 2 pi electron rule, then I call it as aromatic. First 5 examples I gave it for aromatic. This is the system where I'm talking about non-aromatic. Same thing I'll do with the another example. Check here. Okay, now 7th one I'll take here. I'll take up the cyclopropene only, but not a cation. Okay. So cyclopropynyl here, cyclopropene. Propene we have. Is this aromatic if the question comes? Check for it. Ring, of course. Is it planar? Having uninterrupted delocalized system? No. Look at this carbon. E carbon. Idu sp2. Idu sp2. Okay. But E carbon sp3 ಇರೋದ್ರಿಂದ sp3 ಇರೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ? S ಮತ್ತೆ P ಎಲ್ಲಾನು ಬಾಂಡಿಂಗ್ ಅಲ್ಲಿ ಇನ್ವಾಲ್ವ್ ಆಗಿರುತ್ತೆ. You don't have a unhybridized orbital which is having perpendicular like this and take part in delocalization. Benzene ring structure ಅರ್ಥ ಮಾಡ್ಕೊಂಡಾಗ ನೀವು ಅದನ್ನ ಬರ್ದಿರ್ತೀರಾ. Delocalized lateral overlapping of p orbital ಹೇಗಾಗುತ್ತೆ ಅಂತ. ಒಂದು ಕಾರ್ಬನ್ sp3 ಇರೋದ್ರಿಂದ ಇದರಲ್ಲಿ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ಯು ಡೋಂಟ್ ಹ್ಯಾವ್ ಡಿಲೋಕಲೈಸ್ ಪೈ ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ. ಎಷ್ಟು ಪೈ ಎಲೆಕ್ಟ್ರಾನ್? 2 ಪೈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. 4n plus 2 pi electron rule ಸ್ಯಾಟಿಸ್ಫೈ ಆಗುತ್ತೆ. ಬಟ್ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ಡಿಲೋಕಲೈಸೇಷನ್ ಇರಲ್ಲ, ಪ್ಲೆನಾರಿಟಿ ನಿಮಗೆ ಮೇಂಟೈನ್ ಆಗಲ್ಲ. ಸೊ ಯು ಡೋಂಟ್ ಹ್ಯಾವ್ ಡಿಲೋಕಲೈಸ್ಡ್ pi electron system. So delocalized pi electron system is absent because this carbon is sp3 hybridized. Hence this system is also considered as non-aromatic. Okay. Now let us take one more here. I have cyclobutadiene here. Okay. Cyclobutadiene. Fine. Cyclobutadiene. Ella carbon sp2 ring. ಹೌದು, ಎಲ್ಲಾನು sp2 delocalization. Yes, delocalized system we have. But how many pi electrons? 4 pi electron. 4 pi electron ಅಂದ್ರೆ ಹಕೆಲ್ rule satisfy ಆಗಿಲ್ಲ. So this system is also non-aromatic. So this is how we decide. Look the system, see the carbons, ring, of course easy to understand. Then understand the hybridization. If you have any of the carbon sp3, you can't have a delocalized system. Okay, because sp3 ಇದ್ರೆ ಅಲ್ಲಿ ಇಂಟರಪ್ಟ್ ಆಗುತ್ತೆ, delocalization of pi electron ಆಗಲ್ಲ. ಒಂದ್ ಯಾವ್ದಾರ sp3 ಇದ್ರೆ immediately you can decide it is non-aromatic. Then provided with ಎಲ್ಲಾನು sp2 ಆಗಿದೆ, but still if it is not having 4n plus 2 pi electron rule ಇಲ್ಲ ಅಂತಂದ್ರೆ 4n plus 2 pi electron rule ಫಸ್ಟೇ ಬರ್ದಿದ್ದೀನಿ. n is equal to 0 ಅಂದ್ರೆ 2, n is equal to 1 ಅಂದ್ರೆ 6, n is equal to we have 2 ಅಂದ್ರೆ you have 10, like that. If you have 2, 6, 10, 14 pi electrons ಇದ್ರೆ ಮಾತ್ರ 3 conditions complete ಆಗಿ satisfy ಆದ್ರೆ you call it as aromatic. Otherwise they are non-aromatic. So ಇದು ಒಂದು MCQ question ಫಾರ್ ಶೋರ್ ಇದ್ದೇ ಇರುತ್ತೆ ನಿಮಗೆ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಅಲ್ಲಿ. ಇವನ್ ನಿಮ್ ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಇವಾಗ MCQ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಿರೋದ್ರಿಂದ ನಿಮಗೆ ಸಮ್ ಚಾನ್ಸಸ್ ಆರ್ ದೇರ್ ಐಡೆಂಟಿಫೈಯಿಂಗ್ ವೆದರ್ ಇಟ್ ಈಸ್ aromatic or not. Okay, so you can focus on this part. Yes, so this is about aromaticity, important part of this aromatic hydrocarbon. Now we have a small here, one more 3 marks question you will get in your board exam, that is about reactions of benzene. Okay, so before going for reactions of benzene, even from preparation of benzene also you will get some questions, because if you see recent your new scheme for your board exam, you have 15 MCQs, 5 fill in the blanks. There you can observe 2 questions they have asked from aromatic hydrocarbons only, MCQ and the fill in the blanks. So you can understand, even though it is very small, you have a lot of weightage, and 1 3-mark question in your last part will be for sure mechanism of electrophilic substitution. Okay, that's how you can give more importance to this particular concept in your hydrocarbons chapter. ಈಗ first we will talk about in brief. Okay, simple agi preparation and reactions of benzene, important. Okay, reactions of benzene. How to prepare a benzene? Already you have learnt. I'll keep the benzene here. Okay, look at it. Benzene C6H6. So I can put alternate double bonds here. Benzene. One simple method is you can start from ethyne. In ethyne part you have come across this. So I can take ethyne upon cyclic polymerization. Yen beku red hot iron tube, right? At 873 Kelvin, if you pass ethane over red hot iron tube, if you keep and pass ethane over that, it will undergo cyclic polymerization to give what? Benzene. So this is the simple method, which is a reaction of ethane also. Next, I can think about preparation of this benzene by taking here benzene derivative only, that is phenol. Okay, so you have studied about this compound. What is this? Phenol. If I have a OH on the benzene ring, it is called phenol. So phenol to benzene ಏನ್ ಕಾಣಿಸ್ತಿದೆ? OH ಗ್ರೂಪ್ ತೆಗಿಬೇಕು ಅಷ್ಟೇ ಅಲ್ವಾ? ಹೈಡ್ರೋಜನ್ ಇರುತ್ತೆ. ಇಲ್ಲಿ ಬೆನ್ಸಿನ್ ರಿಂಗ್ ನಾವು ಈ ತರ ಬರ್ದಾಗ ಹೈಡ್ರೋಜನ್ ನ ಮರಿಬಾರ್ದು. ಪ್ರತಿ ಕಾರ್ಬನ್ ಟೆಟ್ರಾವ್ಯಾಲೆಂಟ್ ಹೈಡ್ರೋಜನ್ ಇದ್ದೇ ಇರುತ್ತೆ. ಸೊ OH ತೆಗಿಬೇಕಂದ್ರೆ ಏನು? ಯು ಆರ್ ರಿಮೂವಿಂಗ್ ಆಕ್ಸಿಜನ್, hydrogen will be there itself, that is nothing but reduction. So you have to take here zinc dust by passing like zinc dust and phenol. If you heat it here together, this will undergo reduction. So this process is called reduction. Okay, reduction of phenol. This is nothing but we have a cyclic polymerization reaction. Okay, cyclic polymerization. Now, what is the third method? Third method is from sodium benzoate. Benzene, carboxylic acid, benzoic acid, that is sodium salt of benzene carboxylic acid. So we have sodium benzoate here. Okay, ಏನ್ ಮಾಡ್ಬೇಕೀಗ ನೋಡಿ ಇಲ್ಲಿ ಇದಿಷ್ಟನ್ನು ಗ್ರೂಪ್ ತೆಗಿಬೇಕು ನಾನು, ರೈಟ್? ಸೊ ದಟ್ ಐ ವಿಲ್ ಗೆಟ್ ದ ಬೆನ್ಸಿನ್. ದಟ್ ಮೀನ್ಸ್ ಯು ಹ್ಯಾವ್ ಟು ಗೋ ಫಾರ್ ರಿಮೂವಲ್ ಆಫ್ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಹಿಯರ್, ದಟ್ ಇಸ್ ಡಿಕಾರ್ಬಾಕ್ಸಿಲೇಷನ್ ರಿಯಾಕ್ಷನ್. ನೆನಪಿರುತ್ತೆ, ಡಿಕಾರ್ಬಾಕ್ಸಿಲೇಷನ್ ರಿಯಾಕ್ಷನ್ ಓದಿದ್ದೀರಾ ನೀವು ಆಲ್ಕೇನ್ಸ್ ಅಲ್ಲಿ. ಓಕೆ, ಫಾರ್ ದಟ್ ವಾಟ್ ಇಸ್ ದ ರಿಕ್ವೈರ್ಮೆಂಟ್? Soda lime is the requirement. What is that soda lime? It is nothing but sodium hydroxide along with the calcium oxide. So mixture of sodium hydroxide with calcium, because calcium oxide is quick lime, you have heard about it, and sodium hydroxide is caustic, we have, right? Soda. So soda and quick lime, soda lime, lime soda ನೆನ್ಪಿಟ್ಕೊಂಡ್ರು okay, because easy way to remember, sometimes we require, right? Soda with the quick lime here, which is known as soda lime. If I heat it with this, it will remove the carbon dioxide as sodium carbonate, so that gives you the benzene. Okay, only 3 reactions which are very important. Now we need to understand the reactions of benzene. Look at the benzene. You have the double bond. I told you each carbon has a hydrogen. Okay, what is the characteristic reaction? In one of my previous session I have explained organic reaction mechanisms. How do we understand ಯಾವ ತರ ರಿಯಾಕ್ಷನ್ ಆಗ್ಬೋದು, ಹೇಗೆ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದು ಅಂತ? ಈಗ ನೀವು ಬೆನ್ಸಿನ್ ರಿಂಗ್ ಗೊತ್ತಿದೆ ನಿಮಗೆ, ಎಷ್ಟು ಪೈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ? 3 pi ಬಾಂಡ್ಸ್ ಇದೆ, 6 pi electrons delocalized ಆಗಿರುತ್ತೆ, ಅಂದ್ರೆ electron rich. Okay, benzene is electron rich substrate. ಈಗ electron rich substrate ಇದ್ರೆ ಏನಾಗುತ್ತೆ? What kind of reagent should come and attack benzene ring? Will electron rich species only will come and attack? ಆಗಲ್ಲ, ನಿಮಗೆ ಗೊತ್ತಿದೆ. Two strong people ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? ರಿಚ್ ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್ ರಿಚ್ ಇದ್ರೆ ಏನಾಗುತ್ತೆ? ರಿಪೆಲ್ ಆಗುತ್ತೆ, ಯುನೋ ಅಲ್ಲ, ಎಲೆಕ್ಟ್ರಾನ್ ರಿಪಲ್ಷನ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಈಗ ಇಲ್ಲಿ electron rich substrate ಇದ್ದಾಗ ಡೆಫಿನೆಟ್ಲಿ ಇಟ್ ವಿಲ್ ರಿಯಾಕ್ಟ್ ವಿತ್ ವಾಟ್? electron deficient, okay, species. That is nothing but you are attacking reagent. So electron deficient species ಬಂದು electron rich substrate ನ ಅಟ್ಯಾಕ್ ಮಾಡೋದ್ರಿಂದ ಈಗೇನಾಗುತ್ತೆ? ಯೂಶಲಿ ಇಲ್ಲಿ ಈ ಬೆನ್ಸಿನ್ ರಿಂಗ್ ಅಲ್ಲಿರೋ ಪೈ ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ಲೌಡ್ಸ್ ನ ಡಿಸ್ಟರ್ಬ್ ಮಾಡೋದು ತುಂಬಾ ಕಷ್ಟ. ಯಾಕೆಂದ್ರೆ 6 ಕಾರ್ಬನ್ sp2 ಹೈಬ್ರಿಡೈಸ್ಡ್, 6 p ಆರ್ಬಿಟಲ್ ಈ ತರ ಲ್ಯಾಟರಲ್ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಆಗಿ ಈ ತರ ನಿಮ್ ಟೀಚರ್ಸ್ ತೋರಿಸಿರ್ಬೋದು, ಡೋನಟ್ ಕೈಂಡ್ ಆಫ್ ಶೇಪ್ ಇರುತ್ತೆ ಅಂತ, ಪೈ ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ಲೌಡ್ ಅಬವ್ ಅಂಡ್ ಬಿಲೋ. ಓಕೆ, ಒಂಥರ ಬೆನ್ಸಿನ್ ಸಿಗ್ಮಾ ಬಾಂಡ್ಸ್ ಅದ್ರ ಮಧ್ಯೆ ಸ್ಯಾಂಡ್ವಿಚ್ ಆದಾಗಿರುತ್ತೆ. ಸೊ ಇಟ್ ಇಸ್ ಎ ವೆರಿ ಸ್ಟ್ರಾಂಗ್ ಸಿಸ್ಟಮ್, highly stable. Benzene ring is highly stable due to delocalized pi electron system. ಹಾಗಿದ್ದಾಗ ಇದನ್ನ ಈಸಿಯಾಗಿ ಪೈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ನೀವೇನು ಡಿಸ್ಟರ್ಬ್ ಮಾಡಕ್ಕಾಗಲ್ಲ. ಏನ್ ಮಾಡ್ಬೋದು ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್ ಡಿಫಿಷಿಯಂಟ್ ಸ್ಪೀಶೀಸ್ ಅಟ್ಯಾಕ್ ಮಾಡಿ ಈ ಹೈಡ್ರೋಜನ್ ನ ರಿಪ್ಲೇಸ್ ಮಾಡ್ಬೋದು. ಸೊ ವಿ ವಿಲ್ ಫೈಂಡ್ set of reactions for the benzene here. They are called electrophilic substitution. You are going to replace one hydrogen by another. Okay, electrophilic substitution reactions ಆಗುತ್ತೆ. ಯಾವುದೆಲ್ಲ ಎಲೆಕ್ಟ್ರೋಫಿಲಿಕ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ರಿಯಾಕ್ಷನ್ ಆಗ್ಬೋದು ಅಂತ ತಗೊಂಡ್ರೆ ಇಲ್ಲಿ ದರ್ ಆರ್ ಇಂಪಾರ್ಟೆಂಟ್ 5 ರಿಯಾಕ್ಷನ್ಸ್. ಆ 5 ನಲ್ಲಿ ಒಂದಂತೂ ಖಂಡಿತ ಬಂದೇ ಬರುತ್ತೆ ನಿಮ್ ಬೋರ್ಡ್ ಎಕ್ಸಾಮಿಗೆ. ಆಮೇಲೆ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ ಮೇಲೆನೂ ಅದ್ರ ಮೇಲೆ ಕ್ವೆಶನ್ಸ್ ಇದ್ದೇ ಇರ್ತವೆ. ಸೊ ಜಸ್ಟ್ ಐದರ್ ರಿಯೇಜೆಂಟ್ ನ ಐಡೆಂಟಿಫೈ ಮಾಡೋದು ಅಥವಾ ಪ್ರಾಡಕ್ಟ್ ಐಡೆಂಟಿಫೈ ಮಾಡೋದು. ಆಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿ ನೀವು ತುಂಬಾ ಅದ್ರ ಬಗ್ಗೆ ಫರ್ದರ್ ಆರ್ಥೋ ಪ್ಯಾರಾ ಡೈರೆಕ್ಟಿಂಗ್ ಇನ್ಫ್ಲುಯೆನ್ಸ್ ಎಲ್ಲ ಓದ್ತೀರಾ. ಸೊ ಅದಕ್ಕೆ ರಿಲೇಟೆಡ್ ಆಗಿ ಕ್ವೆಶನ್ಸ್ ಬರ್ಬೋದು. ಓಕೆ, ಸೊ ಈಗ ನೀವು ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ ಅಂತ ತಗೊಂಡ್ರೆ ಮೇ ಬಿ ದ ಮೆಕ್ಯಾನಿಸಮ್ ಪಾರ್ಟ್ ನಿಮಗೆ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ we will just first find out what are those 5 important reactions. So I have a benzene ring here, right? So what I will do, I'll give you first all the reactions. Okay, so first here we have, I'll be writing reverse, that is okay for you I think. Okay, first one is halogenation. What is that halogenation? ಯಾವುದೇ halogen ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗ್ಬೋದು. ಸೊ I'll take chlorination. Chlorine ಬೇಕು. Along with that, I need anhydrous. Anhydrous. Aluminium chloride ಅಂದ್ರೆ ಡ್ರೈ ವಿದೌಟ್ ವಾಟರ್ ಆಫ್ ಹೈಡ್ರೇಷನ್. anhydrous aluminium chloride. ಹ್ಯಾಲೋಜಿನೇಷನ್ ಅಂದ್ರೆ ಇಲ್ಲಿ ನಾನು ಕ್ಲೋರಿನೇಷನ್ ಬಗ್ಗೆ ಮಾತಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ವಿಚ್ ಈಸ್ ಯುವರ್ electrophile? Cl plus is your electrophile. Your benzene ring, one of the hydrogen will be substituted here. ಈ ಹೈಡ್ರೋಜನ್ ತಗೋತೀನಿ ನಾನು. ಯಾವುದೇ ಹೈಡ್ರೋಜನ್ ರಿಪ್ಲೇಸ್ ಮಾಡಿ ಬರಿಬಹುದು. ಬೆನ್ಸಿನ್ ಅಲ್ಲಿ 6 ಹೈಡ್ರೋಜನ್ ಒಂದೇ ತರ ಇರುತ್ತೆ. ಅದ್ರ ಬಿಹೇವಿಯರ್ ಒಂದೇ ತರ ಇರುತ್ತೆ, ಏನು ಚೇಂಜ್ ಆಗಲ್ಲ. ಅದೇ ನೀವು ಬೆನ್ಸಿನ್ ನ ಕ್ಲೋರೋಬೆನ್ಸಿನ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ ಆಮೇಲೆ ಅದರ ಪ್ರಾಪರ್ಟಿ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಬಟ್ ಒಂದು ಬೆನ್ಸಿನ್ ಅಂತ ತಗೊಂಡಾಗ 6 ಹೈಡ್ರೋಜನ್ ಈಕ್ವಾಲೆಂಟ್. ಸೊ ಯು ಕ್ಯಾನ್ ರೈಟ್ ಎನಿ ಆಫ್ ದ ಹೈಡ್ರೋಜನ್. ಸೊ ಐಲ್ ರಿಪ್ಲೇಸ್ ದಿಸ್ ಹೈಡ್ರೋಜನ್ ಹಿಯರ್ ಬೈ chlorine. So you have substituted chlorine. So this is called chlorobenzene. ಇದನ್ನ ಕ್ಲೋರಿನೇಷನ್ ಅಂತ ಕರಿತೀವಿ ನಾವು. ಓಕೆ, ಮೆಕ್ಯಾನಿಸಮ್ ಆಮೇಲೆ ನೋಡೋಣ. ನೆಕ್ಸ್ಟ್ ರಿಯಾಕ್ಷನ್ ಹಿಯರ್ ನಮಗೆ ನೈಟ್ರೇಷನ್ ತಗೋತೀನಿ. ನೇಮ್ ಇಟ್ ಸೆಲ್ಫ್ ಇಂಡಿಕೇಟ್ಸ್ ಯು ಆರ್ ಬ್ರಿಂಗಿಂಗ್ ನೈಟ್ರೋನಿಯಂ ಗ್ರೂಪ್, ರೈಟ್? ವಾಟ್ ಇಸ್ ದ ರಿಯಾಕ್ಷನ್ ರಿಯೇಜೆಂಟ್? ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ನೈಟ್ರಿಕ್ ಆಸಿಡ್ ಜೊತೆಯಲ್ಲಿ ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್ ಬೇಕಿದಿಗೆ. ಸೊ ವಿಚ್ ಇಸ್ ಯುವರ್ electrophile? NO2 plus is your electrophile. So benzene ring, hydrogen is substituted by NO2 group. ಇದನ್ನ ನೈಟ್ರೋಬೆನ್ಸೀನ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ನೈಟ್ರೋಬೆನ್ಸೀನ್. ನೆಕ್ಸ್ಟ್ ರಿಯಾಕ್ಷನ್ ಯಾವುದು? ಸಲ್ಫೋನೇಷನ್. ಓಕೆ, ಸಲ್ಫೋನೇಷನ್. What is sulfonation? Reaction with concentrated sulfuric acid. Concentrated sulfuric acid, fuming sulfuric acid. ಯಾವ್ದು electrophile here? SO3 is the electrophile. So you can see hydrogen is substituted by SO3H. Okay, electrophile idu. But during the reaction mechanism, you can understand how the hydrogen will be coming over there. Okay, this is called benzene sulfonic acid. Okay, benzene sulfonic acid. Yes, next reaction ಏನು? Next reaction is Friedel-Crafts alkylation. Named reaction Friedel-Crafts alkylation. ಏನ್ reagent? Any alkyl halide. Okay, methyl chloride with the anhydrous AlCl3. ಯಾವ್ದು electrophile? CH3 plus ಬರುತ್ತೆ ಇಲ್ಲಿ. So you will get a hydrogen here substituted by CH3 group. So this is called toluene or methyl benzene. Toluene, right? One more reaction I'll write here because I don't have a space. So I'll write here. That is nothing but Friedel-Crafts acylation. Okay, Friedel-Crafts acylation. ಇಲ್ಲಿ ಬರೀತೀನಿ acylation. So in the case of Friedel-Crafts acylation, we will take CH3COCl with anhydrous AlCl3. So this is the reagent combination required. Okay, so we'll get hydrogen is substituted by, sorry, electrophile is here CH3C double bond O. Illiritte electrophile. So hydrogen is substituted by COCH3. So this is a ketone substance which is called acetophenone. So you can see 5 set of electrophilic substitution. ನೀವು ಫಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿ ಇದನ್ನ ಲರ್ನ್ ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ ನಿಮ್ದು ಆಲ್ಮೋಸ್ಟ್ ಪಾರ್ಟ್ ಆದಂಗೆ. ಯಾಕಂದ್ರೆ ಸೆಕೆಂಡ್ ಇಯರ್ ಅಲ್ಲಿ ಬೆನ್ಸೀನ್ ಬದಲಿಗೆ we will take chlorobenzene, we will take phenol, we take aniline, we take benzaldehyde, we take benzoic acid. ಒಂದೊಂದು ಗ್ರೂಪ್ ಎಕ್ಸ್ಟ್ರಾ ಬರುತ್ತೆ, ಪ್ರಾಡಕ್ಟ್ ವೇರಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಬಟ್ ಬೇಸಿಕ್ ಐಡಿಯಾ ಏನಿದೆ, ಮೆಕ್ಯಾನಿಸಮ್ will remain same. Okay, so halogenation means you can go for chlorination or bromination suitably. Iodination has some sort of issue, okay, as usual. So you will get, if you go for chlorination, you will get chlorobenzene. Bromination, bromobenzene. Next, nitration andre you will get nitro substituent. Sulfonation means we'll get benzene sulfonic acid. Friedel-Crafts alkylation, alkyl group ಬಂದ್ಬಿಟ್ಟು substitute ಆಗುತ್ತೆ. Acyl group, ಇದು acyl group, Friedel-Crafts acylation, you will get ketone moiety. Okay, so these are the 5 reactions you have, very important. Anyone can be asked. Favorite generally halogenation. Sometimes you can have Friedel-Crafts alkylation also. Any one of these will be definitely asked for 3 marks in your exam for writing mechanism. Okay, after giving the general idea, this halogenation, I'll discuss the mechanism. Steps will remain same for all the reactions except the first step. What is that? Generation of electrophile vary ಆಗ್ತಾ ಹೋಗುತ್ತೆ, ಬೇರೆದೆಲ್ಲ will remain same. Okay, so that's why I'll take one example in detail, rest you can apply the concept there. Okay, so I'll erase this board now. And there are some MCQs based on this also in your competitive exam. So I'll be quickly discussing mechanism of chlorination of benzene. Chlorination of benzene. Yes. Whenever you are asked to write a mechanism, your first thing should be you write benzene and write the required reagent. Chlorination means chlorine in presence of anhydrous aluminium chloride. Hydrogen is substituted by what? Hydrogen is substituted by chlorine, and hydrogen combines with another and forms HCl, because in previous I gave you the skeletal byproducts, you need to understand accordingly. So this is the main reaction. So mechanism has 3 steps. First step is generation of electrophile. Generation of electrophile. So previous case I have shown you how the electrophile anta helidini. How the electrophile? Electrophile is nothing but Cl plus. But a Cl plus heg bantu, that is important. For that you are taking the help of this. ಅಲ್ವಾ, ಸುಮ್ಮನೆ ನಾನು Cl ಬಾಂಡ್ ನ ತಗೊಂಡ್ರೆ ಇಲ್ಲಿ Cl is bonded to Cl, which is a homodiatomic molecule. ನಾನ್ ಪೋಲಾರ್ ಬಾಂಡ್, ಅದನ್ನ ನಾನು ಕ್ಲೀವ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು? ಐ ನೀಡ್ ದಿಸ್ ಹೆಲ್ಪ್ ಆಫ್ ಅನ್ಹೈಡ್ರಸ್ AlCl3. ನೀವು ಓದಿರ್ಬೋದು AlCl3 ಏನಾಗುತ್ತೆ. AlCl3 ನಲ್ಲಿ ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ 3 Cls attached like this. So here you have 6 electrons. Incomplete octet irutte. So it is known as what? Lewis acid. ಅಲ್ವಾ, ಇನ್ಕಂಪ್ಲೀಟ್ ಆಕ್ಟೇಟ್ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ? ಅದು want to accept the electron. So this is a Lewis acid. Okay, so it will take away the electron from chlorine. So here this bond will undergo heterolytic cleavage, generating what? This chlorine now will not have this bonded pair of electron, gets a positive charge, and another chlorine takes away the bonded pair of electron and forms AlCl4 minus. Okay, so this is your electrophile. ಅರ್ಥ ಆಯ್ತಾ? ಈಗ ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ಏನು? Attack of electrophile. Okay, attack of electrophile and formation of carbocation intermediate here. Intermediate ಹೇಗಾಗುತ್ತೆ ನೋಡೋಣ. So you have the benzene ring. Understand, it is very easy. Hydrogen I am showing here comes here Cl plus. Your benzene ring is electron rich, I told. So this is electron deficient. So this pi electrons will be easily shared with the electrophile and forms a carbocation intermediate. Observe the things carefully. You have double bond. This is non-disturbed. This bond is shared with this chlorine. So hydrogen, chlorine gets bonded to this carbon. I'll show. You can attach it to this also. Accordingly, you need to vary the way of writing. Now this carbon has a deficiency of electron because both the electrons are shared with chlorine to form a bond. ಸೊ ಈ ಕಾರ್ಬನ್ ಏನಾಗುತ್ತೆ ಡಿಫಿಷಿಯಂಟ್ ಆಗುತ್ತೆ. ಇದಕ್ಕೆ ಮೂರೇ ಬಾಂಡ್, ಇಲ್ಲೊಂದು ಹೈಡ್ರೋಜನ್ ಇರುತ್ತೆ, 1 2 3, ಸೊ ಇಲೆಕ್ಟ್ರಾನ್ ಶಾರ್ಟೇಜ್, ಟೆಟ್ರಾವ್ಯಾಲೆನ್ಸಿ, 3 ಬಾಂಡ್ಸ್ ಅಂದ್ರೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. ಸೊ ದಿಸ್ ಈಸ್ ಅರೀನಿಯಂ ಅಯಾನ್ ಇಂಟರ್ಮೀಡಿಯೇಟ್. ಈಗ ಏನಾಗುತ್ತೆ, ಆರೋಮ್ಯಾಟಿಕ್ ಇತ್ತು, ಡ್ಯೂ ಟು ದ ಅಟ್ಯಾಕ್ ಆಫ್ ಇಲೆಕ್ಟ್ರೋಫೈಲ್ ಆರೋಮ್ಯಾಟಿಸಿಟಿ ಲಾಸ್ ಆಯ್ತು. ಯಾಕಂದ್ರೆ 6 ಪೈ ಇಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ದಿದ್ದು 4 ಪೈ ಇಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಯ್ತು. ಆರೋಮ್ಯಾಟಿಕ್ ಲೂಸ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಸ್ಟೆಬಿಲಿಟಿ ಇರಲ್ಲ. ಬಟ್ ಈವನ್ ದೆನ್ ದಿಸ್ ಇಸ್ ಬಿಟ್ ಆಫ್ ರೆಸೊನೆನ್ಸ್ ಸ್ಟೆಬಿಲೈಸ್. ನಾವು ರೆಸೊನೆನ್ಸ್ ಸ್ಟೆಬಿಲಿಟಿ ಬರಿಬಹುದು ಹೇಗೆ, this pi electron I can shift over here. So due to the resonance stability, you can have this as a intermediate here, double bond HCl idil baratte. So this part I'll erase, you understood it is a Lewis acid, and then I can shift this pi electron here and write its one more resonance structure. So that is double bond hydrogen and Cl, carbon gets a positive. So these are the two other resonance structures. Okay, so what happens, as I told, aromatic changes into non-aromatic here. Idu immediate agi wants to gain its aromaticity. So last step is removal of proton. So ee proton na horagade bittu, it will immediately comes back to its original aromatic nature. Okay, hydrogen and Cl. What will drive this reaction? Your AlCl4 minus is there, no? Okay, that will help you to drive the reaction. So this bond will cleave and forms aromatic system. H will react with the. So look at the way I am taking. Double bond formed again here and a Cl here. H will react with Cl to form HCl, and your AlCl3 will be back. Okay, understand the reaction, how nice it is. Because benzene is electron rich, so you can't have an electron rich species coming in. You want an electrophile coming in. That electrophile is generated by the help of Lewis acid. Because this is having deficient, so it will take up, but it will give back. That's how. So this will act as a somewhat what, a catalyst, because it will be remaining as it is at the end of reaction. Okay, which will facilitate your reaction. So these three steps writing will fetch you 3 marks. One word you need to write. What is that? Generation of electrophile. AlCl3 will generate the electrophile being Lewis acid, takes away the chlorine in form of minus and forms the electrophile. Attack of electrophile and formation of carbocation intermediate. Okay, this is how, and its resonance structures. Third one, removal of proton will give you the final product. So this is the important mechanism. Okay, now ಬೇರೆಲ್ಲ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ಏನೀಗ ನೈಟ್ರೇಷನ್ ಅಲ್ಲಿ ಏನ್ ಬರುತ್ತೆ, ಕ್ಲೋರಿನ್ ಬದಲಿಗೆ ಐ ನೀಡ್ ಟು ಯೂಸ್ ನೈಟ್ರೋನಿಯಂ ಅಯಾನ್. ಸಲ್ಫೋನೇಷನ್ ಅಲ್ಲಿ ಸಲ್ಫೋನಿಕ್ ಗ್ರೂಪ್ ಬರುತ್ತೆ. ಫ್ರಿಡಲ್ ಕ್ರಾಫ್ಟ್ಸ್ ಆಲ್ಕೈಲೇಷನ್ ಅಲ್ಲಿ ಆಲ್ಕೈಲ್ ಗ್ರೂಪ್ ಬರುತ್ತೆ. ಸೊ ಬೇರೆಲ್ಲ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ಇದು ಒಂದು ಬಿಟ್ರೆ ಬೇರೆಲ್ಲ ಸ್ಟೆಪ್ಸ್ ವಿಲ್ ರಿಮೇನ್ ಸೇಮ್. ಅರ್ಥ ಆಯ್ತಾ? ಈಗ ಒನ್ ಮೋರ್ ವಿ ವಿಲ್ ಟ್ರೈ ಹಿಯರ್. ವಾಟ್ ಐ ವಿಲ್ ಟೇಕ್, ದಿಸ್ ಇಸ್ ಕ್ಲೋರಿನೇಷನ್, ರೈಟ್? ಸೊ how easily you can understand, you try here. I'll change this, I'll put CH3Cl. Okay, so what happens, AlCl3 Friedel Crafts alkylation first ಮಾಡ್ತೀನಿ ನಾನು, so that ನಿಮಗೆ ಈಸಿಯಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ. CH3 ಟಾಲಿನ್ ಬರುತ್ತೆ. ಈ Friedel Crafts alkylation ಅಲ್ಲಿ only difference is CH3, correct? So illu the same way this CCl bond will be heterolytically cleaved and you will get a CH3 carbocation here. This is electrophile. Now instead of chlorine, you have a CH3 over here. Okay, that will come and attach to the benzene ring, and then you will have the removal of proton to get what? So my job is easy. I can do the changes over there only for your understanding. That's what I told. One mechanism if you work, rest of the reactions are all same except the first step, generation of electrophile. So here we will change this into CH3 and final product will be changed here, CH3. This is Friedel Crafts alkylation. How do we write for Friedel Crafts acylation? Try. In case of Friedel Crafts acylation, what I need to change? I need to change this, right? So I need to take acetyl chloride instead of methyl chloride here, right? So let us change this Friedel Crafts acylation, CH3 COCl. So this group will be CH3CO CH3 here. My job is easy. Again look at it. The groups are same here. CH3 C double bond OCl. Correct? CCl bond is subjected to cleavage. So because Cl is negatively charged here because it's more electronegative than the carbon. So your electrophile will be CH3 C double bond O, positive charge. Correct? ಇಲ್ಲಿ ಬರುತ್ತೆ electrophile ಇವಾಗ CH3 C double bond O. Now I'll change the arrow, show it to this because this is the electrophile. So your product will be C double bond O CH3. Correct? Here the product will change into acetophenone. First I have written all skeletal structures for your understanding. COCH3. Correct? That's all. So that's what I told. One mechanism, all you can write. But when I talk about nitration, ಸ್ಲೈಟ್ಲಿ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಒಂದೊಂದ್ಸತಿ ಆ ನೈಟ್ರೇಷನ್ ಪಾರ್ಟ್ ಅಲ್ಲಿ ಸಣ್ಣ ಕ್ವೆಶ್ಚನ್ ಕೇಳ್ತಾರೆ, ದಟ್ ಇಸ್ MCQ ಫಾರ್ ದ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್. ಈಗ ಇಲ್ಲೆಲ್ಲ ಏನು ಡೈರೆಕ್ಟ್ MCQs ಇರ್ತವೆ. ಗಿವನ್ ವಿತ್ ದ ರಿಯಾಕ್ಟೆಂಟ್ ನೀವು ಐಡೆಂಟಿಫೈ ಮಾಡಬೇಕು, ದಟ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಇದು ತುಂಬಾ ಬೇಸಿಕ್. ಬೆನ್ಝೀನ್ ಹೋಗ್ತಾ ಹೋಗ್ತಾ ಹೈಯರ್ ಕ್ಲಾಸ್ ನೆಕ್ಸ್ಟ್ ಇಯರ್ ಸ್ಟಡಿ ಮಾಡ್ತಾ ನಿಮಗೆ ತುಂಬಾ ರಿಯಾಕ್ಷನ್ಸ್ ಬರ್ತವೆ ಇದೇ ತರದ್ದು. ಈಗ ನಾನು ಅಸಿಟೈಲ್ ಕ್ಲೋರೈಡ್ ನ ಅನ್ಹೈಡ್ರಸ್ ClCl3 ನೋಡ್ದೆ ಅಲಾಂಗ್ ವಿತ್ ಎನಿ ಬೆನ್ಝೀನ್ ಅಂತಂದಾಗ ಐ ನೀಡ್ ಟು ರೀಕಾಲ್ ಇಟ್ ಆಸ್ ಫ್ರಿಡಲ್ ಕ್ರಾಫ್ಟ್ಸ್ ಅಸೈಲೇಷನ್. ಅದೇ ಮೀಥೈಲ್ ಕ್ಲೋರೈಡ್ ವಿತ್ AlCl3 ಬಂತು ಬೆನ್ಝೀನ್ ರಿಂಗ್ ಅಂತಂದ್ರೆ ಐ ನೀಡ್ ಟು ರೀಕಾಲ್ ಫ್ರಿಡಲ್ ಕ್ರಾಫ್ಟ್ಸ್ ಆಲ್ಕೈಲೇಷನ್. ಅದೇ ತರ ಬೆನ್ಝೀನ್ ವಿತ್ ಕ್ಲೋರಿನ್ ಇನ್ AlCl3 ಅಂತಂದಾಗ ನಂಗೆ ನೆನಪಾಗಬೇಕದು ಕ್ಲೋರಿನೇಷನ್. ಅಂದ್ರೆ ಇವೆಲ್ಲ ಇಲೆಕ್ಟ್ರೋಫಿಲಿಕ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ರಿಯಾಕ್ಷನ್ ಅನ್ನೋದು ನನ್ನ ತಲೆಗೆ ಇಮಿಡಿಯೇಟ್ ಕ್ಲಿಕ್ ಆಗಬೇಕು. ದಟ್ಸ್ ಹೌ ಲೈಕ್ ನೀವು ನೋಡ್ತಾ ನೋಡ್ತಾ ಕಲಿಬೇಕು ಅದನ್ನ. ಬಿಕಾಸ್ ಅದು ಗೊತ್ತಾಯ್ತು ಅಂದ್ರೆ ನಿಮಗೆ ಪ್ರಾಡಕ್ಟ್ ಐಡೆಂಟಿಫೈ ಮಾಡೋದು ಏನೂ ಕಷ್ಟ ಆಗಲ್ಲ, ತುಂಬಾ ಈಸಿ ಪಾರ್ಟ್ ಅದು. ಓಕೆ, ಸೊ ಇವೆಲ್ಲ ಸಿಮಿಲರ್. ಕ್ಲೋರಿನೇಷನ್, ಫ್ರೆಡಲ್ ಕ್ರಾಫ್ಟ್ಸ್ ಆಲ್ಕೈಲೇಷನ್ ಅಂಡ್ ಅಸೈಲೇಷನ್ ಎಲ್ಲ ಸಿಮಿಲರ್. ಓಕೆ, ನಾವು ಕಮಿಂಗ್ ಟು ದ ನೈಟ್ರೇಷನ್ ತಗೊಂಡಾಗ ನಿಮಗೆ ಸ್ವಲ್ಪ ಮೆಕ್ಯಾನಿಸಮ್ ಡಿಫರ್ ಆಗುತ್ತೆ ಇಲ್ಲಿ. ಯಾಕಂದ್ರೆ ಯು ಡೋಂಟ್ ಹ್ಯಾವ್ ಎ ಲೂಯಿಸ್ ಆಸಿಡ್, ರೈಟ್? ಸೊ ನೈಟ್ರೇಷನ್ ಅಂದಾಗ ಯು ವಿಲ್ ಟೇಕ್ ನೈಟ್ರಿಕ್ ಆಸಿಡ್ HNO3 ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಅಲಾಂಗ್ ವಿತ್ ದ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್ ತಗೋತೀರಾ ಅಲ್ವಾ? ಸೊ ವಿಲ್ ಗೆಟ್ ಎ ನೈಟ್ರೋಬೆನ್ಝೀನ್ ಓವರ್ ಹಿಯರ್. ಕರೆಕ್ಟ್, ನೈಟ್ರೋಬೆನ್ಝೀನ್. ಈಗ ಇಫ್ ಯು ಲುಕ್ ಇನ್ ಟು ದ ಜನರೇಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಫೈಲ್ ಹೇಗಾಗುತ್ತೆ ಅಂತ ನೋಡಿದ್ರೆ, ಬಿಕಾಸ್ ಬೋತ್ ಆರ್ ಆಸಿಡ್ಸ್, ಒಂಥರ ಸರ್ಪ್ರೈಸಿಂಗ್ ಆಗಿರುತ್ತೆ ನಮಗೆ ಇದೆಲ್ಲ ರಿಯಾಕ್ಷನ್ಸ್. ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡು ಆಸಿಡು, ನೈಟ್ರಿಕ್ ಆಸಿಡು ಆಸಿಡು. ಸೊ ಎರಡು ಆಸಿಡ್ಸ್ ಇದ್ದಾಗ ಹೇಗೆ ಆಸಿಡ್ ಆಸಿಡ್ ವಿಲ್ ರಿಯಾಕ್ಟ್ ಅಂಡ್ ಗಿವ್ ಅಸ್ ಸಮಥಿಂಗ್, ರೈಟ್? ದಟ್ಸ್ ಹೌ ವಿ ನೀಡ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಈಗ ನಾನು ಜನರೇಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಫೈಲ್ ಮಾತ್ರ ನಿಮಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ ಇಲ್ಲಿ. ರಿಮೈನಿಂಗ್ ಸ್ಟೆಪ್ಸ್ ಯು ಕ್ಯಾನ್ ರೈಟ್ ಬಿಕಾಸ್ ದೇ ಆರ್ ಆಲ್ ಸಿಮಿಲರ್. Okay, so if I look into the structure of sulfuric acid, you have S double bond O, right? OH and OH here. Nitric acid, if you look into the structure, you have N, here HNO3, right? Yes, so this will be the coordinate bond you can find here. Okay, or I can write it as NO2 ಅಂತನೂ easy ಮಾಡಿ ಬರಿಬೋದು ನಿಮಗೆ ಇಲ್ಲಿ. Okay, I'll write this as NO2, so easy way. Now ಎರಡು ಆಸಿಡ್, but one will behave as stronger than the other. So in this case, this will give the proton to nitric acid, and because this is a stronger acid because it's conjugate base, ಸ್ವಲ್ಪ equilibrium ಅಲ್ಲಿ. Yes sir.
Sir,
2
I
minutes.
you have to take another 5 minutes.
ಒಂದು 2 minutes ಸಾಕು ಸರ್, ಇದೊಂದು ರಿಯಾಕ್ಷನ್ ಅಷ್ಟೇ.
Okay.
5 minutes ಆದ್ರೂ ಓಕೆನಾ?
No, okay, ma'am. Okay,
just ಇದೊಂದು ಹೇಳ್ಬಿಟ್ಟು I'll wind up sir.
Okay.
Okay, so guys, so this is a stronger acid here. ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ, no, it's like stronger acid. It will give the proton to your nitric acid and forms. Look at the reaction. ಯಾಕೆಂತಂದ್ರೆ ಈ ಕಾಂಜುಗೇಟ್ ಏನು ಬೇಸ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ, ಅದು ಸ್ಟೇಬಲ್ ಆಗಿರುತ್ತೆ, ರೆಸೊನೆನ್ಸ್ ಸ್ಟೆಬಿಲಿಟಿ ಬರುತ್ತೆ. So you will be having here HSO4 minus, and this will attach to this, so you have OH2 formation with a positive charge, NO2 ಇರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ವಾಟರ್ ಫಾರ್ಮ್ ಆದಾಗ ಈ ಸ್ಟೆಪ್ ಅಲ್ಲಿ this may not be stable at all, that gives out the water molecule easily. So NO2 we have, okay, NO2 ಆಕ್ಸಿಜನ್, ಹೈಡ್ರೋಜನ್ ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. ಈ ಬಾಂಡ್ ಕ್ಲೀವ್ ಆಗಿ, ಹೀಟ್ರೋಲಿಟಿಕ್ ಕ್ಲೀವ್ ಆಗಿ, you will get a electrophile here. That is nothing but this is water molecule. Look at it, water and NO2. ಅಂದ್ರೆ ಇಲ್ಲಿ ಏನ್ ಕ್ವಶನ್ ಬರುತ್ತೆ ಅಂತಂದ್ರೆ, ಎರಡು ಆಸಿಡ್, ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್, ನೈಟ್ರಿಕ್ ಆಸಿಡ್. ಈಗ ಇದು ಪ್ರೋಟಾನ್ ನ ಇದಕ್ಕೆ ಕೊಡ್ತಾ ಇದೆ, ಅಂದ್ರೆ ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್ ಬಿಹೇವ್ಸ್ ಆಸ್ ಆಸಿಡ್, ದಿಸ್ ಇಸ್ ಆಕ್ಸೆಪ್ಟಿಂಗ್ ದ ಪ್ರೋಟಾನ್. ನಿಮಗೆ ಗೊತ್ತು ಪ್ರೋಟಾನ್ ಆಕ್ಸೆಪ್ಟರ್ ಇಸ್ ನೋನ್ ಆಸ್ ವಾಟ್ ಹಿಯರ್? ಬೇಸ್. right? Because you know the concept of Bronsted acid base, Lewis acid base, Arrhenius acid base. So according to the Bronsted concept, proton donor is acid, proton acceptor is a base. So nitric acid adruno, it behaves as a base. So there's a usual question you will get in MCQ part. Okay. So once you understand this formation of nitronium ion, then attack it to the benzene ring and form a sigma complex or arrhenium ion, then deprotonate it and get the final product. Okay. So this is all about your electrophilic substitution reactions. So if you concentrate on this, you will get 3 marks for sure in the final board exam. Hope with this we can stop. If you have any doubts, you can ask. Yes, students, it's over to you. Because of the time constraint, we cannot further proceed also. A small part ortho para directing influence, you can read through it. So if you have any doubts particularly, you can ask.
Soumya madam, thank you very much.
Thank you, sir.
Very nice talk. Students won't ask questions directly. They're a bit shy.
Okay. Yeah.
We'll send through email. We'll
Sure,
be
sir.
forwarding
Sure,
it.
sir.
You can.
Sure, sure, sir. Sure, sir.
Thank
Okay, then. Thank you so much, sir.
to the participants. We are very grateful to you for this excellent talk. I'm sure students will get a lot of take-home message from your talk. We'll be inviting you again for another topic. Thank you
Sure,
very
sir.
much.
Thank you. Thank you so much, sir. Thank you.
Good evening, sir. Kushal Das, sir. Dr. Anil, welcome to.
Good evening. Good evening. Good evening, sir. Good evening very much. Yeah, Dr. Anil is also here.
Welcome to
Good
both
evening,
of
sir. Good evening. Thanks for the opportunity, sir. Thank you.
Students, good evening. Today we have with us Dr. Anil Kumar Reddy, sir. On behalf of all of you, I welcome Doctor to deliver his talk. Before that, I would like to give a brief overview of his achievement. Dr. Anil Kumar Reddy, sir, is Associate Professor in Pathology in Sri B.M. Patil Medical College Hospital and Research Center, BLDE, Vijaypur. Sir has done his MBBS from PS Institute of Medical Sciences and Research, Chittoor district, Andhra Pradesh. Later pursued his MD in Pathology from Sri B.M. Patil Medical College Hospital and Research Center. Then after his post-graduation in medicine, he is pursuing a postgraduate certificate course in artificial intelligence and deep learning from the reputed Indian Institute of Technology, Guwahati. In fact, doctor, it is a very rare combination that after your medicine, you are doing the artificial intelligence. Is really very inspiring for all the students present here. People think that those who are in biology need not have to go to engineering, and the engineers think we do not have to go to biology. Now, silos is not there. Everybody has to learn everything. You are a good role model for our students to learn all subjects equally well. Thank you, doctor. And work experience, doctor has worked as a junior resident at the reputed NIMHANS for 1 year. Later, he joined as assistant professor in 2018, and he became associate professor and in 2022 till date at Sri B.M. Patil Medical College. He was also a scientific officer from 2020 to 21 in Tata Memorial Center, Advanced Center for Treatment, Research and Education in Cancer Imaging Biobank project. He's also a freelance editor from 2020 to till date, and is author Matrix, publication 16, citation 13, HNS 13, and to his credit, he has 2 patents: interchangeable camera attachment for binocular microscope and digital anatomase learning table. With this brief introduction, I request Dr. Anil Kumar Reddy sir to take over and deliver his talk. Over to you, Doctor.
Thank you, sir. Thanks for your words and introducing me to the students. I also thank my institute for giving me this opportunity, and especially Das sir and my dean sir, who has helped me in getting into this forum. And if the share button is enabled, I'll start with my PowerPoint, sir. So because keeping the students in mind, I don't want to use the jargon or complicated words, and I like to keep it very simple, and I'll try to explain what artificial intelligence, what we do usually as healthcare professionals, and how much we are going to delve into the topic of artificial intelligence. As a medical person, my knowledge is shallow in this particular subject, but as it is required to my level, I have learned those things, and I am pursuing even better things. So with that brief introduction, let me just start.
Now we can share the.
Yes, sir. So is the screen visible, sir?
Yes, sir. Visible, sir.
Okay. So there is this aura about the artificial intelligence, like what it is, how it is happening, where are these models, how it happens, and how the people will train it, and where it will be used. So let's just see what the definitions is. Like any subject you people pick up, you are supposed to read the definition first, and you are supposed to understand what it is based on the definition. The definition looks complicated, and it is like 3-4 sentences here. It is stating as refers to the simulation of human intelligence in machines that are programmed to think and learn like humans. These machines can be trained to understand and process information, make decisions, all jargon sort of thing. And to further complicate it, we see such things like artificial intelligence, machine learning, deep learning. You keep hearing these multiple terminologies, even though they are more or less an overlap and there is some exclusion of one event and the other event. But that is not how I am going to talk to you people, or that is not how I am going to explain things to you. What I want to say is, let's understand what actually it is. In simple words, if a machine can perform what a human intelligence can perform, such as like we are able to see on the road and we are able to identify this is a person, this is a car, this is a truck here, and I can go now or I cannot go now. We make these decisions while we are seeing the road. And if a artificial intelligence based self-driving car can do this, that is called as visual perception has been mastered by the machines. So we are not there at that level that a car can drive it on its own. Multiple companies are trying to do this and achieve this. For example, Tesla is one company which is trying to do this. Google self-driving car is one other company which is trying to do this. So this is something about visual perception, when artificial intelligence focuses on visual perception. Or if you ask some question to a machine, and if the machine is able to interpret what you are asking, in which language you are asking, and understand the context of it, and then interpret it, again, that is coming under voice recognition, speech recognition. So there are multiple companies again in this. Some of you might be having these things in your home, or you might have seen some advertisements about these things. Google, Microsoft, even Amazon, and even Apple, all of these things are having these voice recognition devices. So now the systems are moving towards not only having voice recognition, they are understanding the text what you have given them, or the speech what you have given them, and they are doing some tasks for you. Your new laptops might be having this, your mobiles are equipped with these things. There is Google Assistant in most of your smartphones, and even Apple ka Siri is having all these things. So they are also growing and more useful. Two people are conversing, and if the persons are not understanding their language, again instant machine translation and from one language to other, and that is converted to speech. And this might be helpful to some of our postgraduates who are postgraduates and undergraduates who are getting all over India seats now, and local languages is big trouble. So now artificial intelligence are coming even towards language translations and even Indian languages are being. If you go into Google website and Google Translate, you can even translate the English language even to Kannada, even Telugu. All the local dialects also are being supported. Most of this happens through artificial intelligence, and human interference also is there, wherein they are being continuously retrained and upgraded in how they are doing that task. So this photo states this person is a champion of a game called Go, which is a Chinese game. There are 10 to the power of 360 number of moves in this game, and Google's deep mind has defeated the world champion in this game. And they are almost, if a particular focus has been given to the machine learning model, it is trying to replicate human level of achievement in that particular focused area. So fine, awesome. So is software. We have been using the software for a long time. What is so great about artificial intelligence? So for a software, you are supposed to tell the software explicitly like what you are supposed to do if a user taps on a button or if the user moves the mouse to a particular area, what you are supposed to do. This is programmed into the software. Whereas artificial intelligence, it need not be given such explicit interventions. So for example, if I ask you people, do you remember your way back from home to school daily? So did somebody tell you to remember that, or because you are doing it repeatedly every day in and day out for the past so many days, if you are moving to the school from home, you observe knowingly or unknowingly your what to say, like on the road where there is a right turn or left turn, and how I am going to reach back, and something is changed in the road area where you are taking, there is a new speed bump somewhere, you are going to understand all these things. So that is something which you have picked up without explicitly being told to understand those things or observe those things. So in AI, this is how it more or less understands and picks up the learning mechanisms. So for example, you moving from your home to school and every day you are doing this, and nobody is telling you to observe these things, and you have picked up on these things. This is something what in artificial intelligence parlance they call it as unsupervised learning. Whereas if somebody explicitly tells you, so you are supposed to do 2 into 2 4, somebody has taught you this, so this is called as supervised learning. So this programming of the tasks, particular tasks, is completely eliminated in majority of the models. So as I was saying, let's see how, if somebody has to program a model or a software to play this game, there are close to 250 moves for every single move they make. So for example, the person makes a move from here, there are 250 possibilities, and if the person selects the next move, again there are, so it is, point being, literally it is impossible to code the software. But in AI, it picks up on training, like how it has been played before. It sees that those videos, and based on the input it gets from that, and it tries to win, and it tries to win in minimum number of moves. So there are two networks here as seen here, like value network and policy network. So it understands how it is supposed to play the game on its own. So fine, we have seen briefly about how they learn things, but where are these models? Like, are they physical models? Are they in a particular compartmentalized box, or are they in a software package, or where they are? These models, they can be seen in huge data centers or cloud centers. Your Gmail has an attached Google Drive account wherein you can upload the images to that Google Drive link or Microsoft Drive link, cloud data links. So similarly, they can be there in your laptop. In this example, this is a particular artificial intelligence model wherein it can convert text to images. So this is developed by a company called OpenAI. Again, it is free to use, or it can be there even in your mobile operating system, wherein you can use, as in this example we are seeing, it is identifying each and every joint in this person, ankle, knee joints, hip joints, and how it is being moved and how they are moving. So how these things are being interpreted in healthcare, it is being used to train. Here in this example, if you see, the person's knee joint is identified here, and then the ankle joint is identified, and there is a gamification system wherein it helps the patient to repeat so many number of exercises. Like for example, he has to raise the lower limb, and he has to put the limb back. So that is counted as 1. And if he reaches 20, a star pops up. You have seen this in your games, right? Like when you are playing any of the Candy Crush or any of the games, the instant messages keep coming to keep on encouraging you. So similarly, this artificial intelligence model will help any person who is undergoing physiotherapy after, let's say, he has a fall and he had a fracture, and now he is undergoing rehabilitation or training programs to regain his lost strength and build more muscle around that injury and coming back to the school normally. So this kid will be aided by artificial intelligence systems to have complete recovery. Okay. And there are other models, just like what we have seen is called as pose classification model. So there are other models, like for example, if you use images, then it is called as image classification. You want to know what is there in that particular image, it is called as image segmentation. And now I am speaking to you guys. This can be called as some human is speaking, and if nobody is speaking, it will come as. I'll show some examples based on that. There are again video classification and even neural style transfers. So let's see an example. So in this case, this is a freely available, uh, just a minute. So this is a freely available play area for you people wherein you can interact. You can train an artificial intelligence model using images, audio, or pose. Let me take quickly to this image classification model. So here I will say class 1 as Anil is happy. So now I'll click on this webcam button. Sorry for that. Just give me a minute. So I need to stop the video for this. That's the problem. Sorry for that. Okay. So now I am holding and I am saying Anil is smiling. So let me click. Okay, there are 113 images, and I say Anil is not smiling. So now I have created two classes, one as whichever label you give, and I have some images where I am not smiling. I can go through this and I can go through this, whichever is not proper, I can delete those things. So essentially what we have done now is we have created a data set wherein one data set or one class where we label it as Anil is happy, and the other class Anil is not smiling. So once I click on train the model, it tries to go through all these image classes, like one in happy, one in not happy, and the model trains itself. And now you can see that it is trying to place the webcam input, wherein if I stay quiet, it is preferring Anil is not smiling, and if I smile, so this is essentially how we train a teaching learning transfer learning model. So what is this transfer learning model? Like you people have learned from your first standard to 8th standard, 10th standard. Now you know what is English. Now you know what is physics. Now you know what is biology, all these things. So the teacher doesn't say to you people like what is a question, how do you write answer. So those skills you have picked up already. So if you are using the same skills again now, so based upon already learned skills from your earlier standards, but in your +1 +2 you will learn specific subjects. But essentially what a teacher does, you know, all these things. Similarly, now whatever example we have seen that Anil is smiling or Anil is not smiling, is also a transfer learning model wherein people have already trained previously based on images. Now I can sit here and use that model and train our data. In this example, Anil is smiling or Anil is not smiling, and then we can, one second, let me just start the video. Okay. So in healthcare, using these models, some of you might have seen or heard about Stephen Hawking, who was restricted to the wheelchair. So based on his muscle movements, a computer program used to prepare sentences and then create this speech. So something of that sort has been done using this transfer learning model in Mr. Steve. Even he communicates with the his family members and his surroundings, people who are there. And here an artificial intelligence model is helping him to communicate based on his facial gestures. So as I said, example earlier, supervised learning, unsupervised learning, that's how an artificial intelligence model majority of the times learns. So some of you or most of you might have used this uh, Google Maps. If I want to reach some place, I will enter into the Google Maps application and I will type in, and Google tells me not only the distance but also the probable time with each route. So, and this can be done anywhere in the world, right? Like even if you don't know where you are going, you can just pick it up, and if the place is name of the places, you can go through that. So but do you use it to navigate from your school to home, or from your local general store or a medical store and then getting back to your home? No, right? Similarly, we are healthcare is at that level wherein complex problems are being tackled by bigger corporations like Google, Microsoft. They are trying to see how a person responds by compiling his data over time, like multiple blood investigations are being taken, multiple chest x-rays are being taken, and his or her height and weight are being captured, and then they are trying to predict who will fall ill. Even Microsoft is doing, like, they are trying to capture what diseases we are prone to, what diseases we might get in the future. So that is one side of artificial intelligence in healthcare, which is happening. The other side of artificial intelligence in healthcare in India specifically, uh, our university also falls under this category. We are approaching it in a slightly different way. We are approaching it like this. So as I am a pathologist, I see under a microscope and I evaluate whether malarial parasite is present in a person or a tuberculosis organism caused by acid fast bacilli. So this person who presents with cough and fever and weight loss, usually if he is having prolonged duration of cough, we suspect tuberculosis. So during that time, we do some stain, we add some color to that particular sputum what the patient coughs out, and we try to see whether it is having acid fast bacilli or this tubercular bacilli. So this is usually a skill, and this is a national health program in India where we want to control the tuberculosis. So but if I say that if acid fast bacilli detection model has to have a digital slide wherein complex machines are needed to make those digital slides, but in our university, what we are trying to do, without the need for these complex machines, we are trying to make it in a small mobile phone itself, which can classify these things. Such approaches are being taken by majority of the researchers as well. So this is how broadly artificial intelligence is being used in healthcare. So imagine if you are training a model, and if it is remembering that, and you can train n number of times, multiple times the same model, and even our generation, next generation, and the next generation will have access to this model. So here on the left side we are seeing the famous Charaka, who has written Charaka Samhita. And if somehow an artificial intelligence model can literally translate this and make the data available to us, and if we can train in the similar way the person who has suggested hand washing, or the person who has suggested vaccination for rabies, or our own examples, Dr. Manjunath and Dr. Devi Shetty, if their heart operation skills can be incorporated into an artificial intelligence based robosurgeon, so how good it will be. Like, those skills are not lost after the doctor is gone, and we can retrain the model can pick up. So this is a sort of good scenarios wherein the artificial intelligence doesn't turn evil and it doesn't end the world. But in a best scenario, good scenario, what as medical professionals we want, there should not be any loss of skill transmission. Like right now, a student is trained by a cardiologist, a student is trained by different specialties. So what if the student is good at all the things and he can focus on one specific thing in a very good way, and he doesn't forget it, or the world doesn't lose that student after this person dies, or for whatever reason is not able to practice medicine. So to achieve this very good goal, or to achieve these models which are going to uh, do all these works for you, we should need large amounts of data. For your information, we are already generating huge amount of data. See this one single example. Data per day processed by Google is 24 petabytes. That's close to 24,000 hard disks with 1000 terabytes. And this metric, like video uploaded to YouTube every minute. So every minute humanity is uploading 20 hours of data. So there is video classification, and there are multiple skills which are being explained with the video, and we can train multiple machine algorithms on this data. And so is India lacking? We are anywhere behind? No. India is also very much engrossed in these technologies, and there are multiple apps doing this. And recently you might have heard some of the companies are launching even 5G. So we are at a place wherein we are already ready, and we have the entire data which is being collected from us every day in and day out. And some of the corporations, big companies, are using this data to train models. So how much data is being collected, and how big is this data that is being collected? Just to see an example, this is, I have my location enabled in my Android mobile, and this is how the Google captures. In the last 1 year, I have visited 44 cities. I have visited 147, of which 114 places are new. Like, if you ask me, do you remember all these things? Maybe I might remember 4 or 5 cities which I have visited, and the other things I might not remember. And it has even put a number of kilometers traveled, like 13,264 kilometers have been traveled, and in that 2,116 is low emission travel. And it gives a nice pictorial representation of the cities also where I have visited. So imagine if from one person in 1 year, it can generate so many of data points, or so many of details, where I have been to, how many times I have been to. If we see, I was there in these places and so many days, and all these data points which are being captured by the Google. So this is how it has successfully trained an artificial intelligence model wherein it predicts. So for example, if I sit and type Bangalore, and if I want to get directions to Bangalore from Bijapur, so it has already captured multiple data points, like by car how much time it will take, by train how much time it will take, by bus how much time it will take, and all that data is there. So now today, it doesn't know what is the time it will take at the time I am searching to reach Bangalore. So using artificial intelligence model, it will create a prediction and tells me that it might take 10 hours, it might take 15 hours, it will take my data also into account, the people who have traveled on this road also into the account. And such huge amount of data is being collected already, and we are willingly giving the data. So similarly, even health data is being collected in US and UK, and in majority of the developed nations, the health data is being collected, and it is being used for good measures. Even our government is trying to collect this health data in a central place. And today we can go into any of the states and get to know what is the blood bags available. There is a website called Rakta Kosh. Government has connected all the blood banks, and you can understand what is the blood stock available, which group blood is available in a particular blood bank in a pin code level. So this data is already made available. So now this data can be used in training an artificial intelligence model and predict the requirement of blood in a particular area, or where it has been wasted. So how it can be used, who is searching for that. So the complex web of network can be created based on this particular data. So let me show you a small example how powerful these models can be when you train it using certain amount of data. So again, this is a some of you might have heard in WhatsApp or even in YouTube about this chat GPT. So it is a language model wherein it has been trained using some 570 GB of text data. So your letter which you have written, your email which has been sent to somebody, or there is a publicly available website data or Wikipedia data. So all these things have been taken up and it has been trained. This is the general user interface. If you type in the text here, it will try to give an answer. So is it foolproof? No. I have asked it, can you write an essay about KSTA in Karnataka in India? So what it has told me, it has told me that Karnataka State Transport Authority is responsible for transportation in Indian state. So because I didn't mention what it is, it has given me the most probable answer. So I tried to correct it. I am talking about technology KSTA. So then it has understood that the model has understood that it has made a mistake, and it is telling me, I apologize for any confusion. The Karnataka State Technology and Science Academy, and it starts writing an essay about KSTA. Okay. So let's see how powerful this model is. I asked it to say hello to you guys, like hello students, and write that in all the languages it knows. So it started writing in French, Japanese, even Russian, and even in Hindi, Bengali, and Punjabi also. And it has even given me English transliteration, like how I should pronounce that languages as well. So this has happened over the past 1.5 years with just 570 GB of data. So imagine if this model is being trained on the data which we are generating over time, and if it has access to all the research published in medical journals, how much refined search it is going to do. If I am not wrong, and if those people, this OpenAI company who has developed this chat GPT, if they are not very profit oriented, this is how we might be searching for information instead of Google website. So this gives a ready-made answer, and it will give you even where it has taken the information from and what you should do. It can even write the code in Python, HTML, or website. It can design even websites, and the capabilities are being tested right now. So not just language models, people are trying to put this artificial intelligence model into robots. So on the left side, we are seeing this company called as Boston Dynamics, wherein natural walking models have been incorporated into these robots. They can lift the weight, they can clear the obstacles on their own, they can move forward, bring something back to the particular person who has instructed it to do so through voice commands. Or if you tell uh, a particular robot to do a particular task, it will repeat it continuously without doing any mistakes as much as possible. If it does the mistakes, it will rectify itself. So such how that's the power of these machines. And are they foolproof? No, we are not there yet. On the right side, even Tesla is trying to build one more artificial intelligence based robot. It is saying that it is going to be friendly and eliminates dangerous and repetitive boring tasks. What are the implications of it? How successful? Time only will tell us. So this I have shown. This is another example of how you can train even audio in these artificial intelligence models. So coming to healthcare proper, how we are So what data we are going to give the model and what the models might help us in healthcare. We are going to give the model the data regarding your blood investigations. You might have given a blood sample, an injection has been given and some amount of blood has been taken, and then X-ray images. Whenever some of you might have an experience, you have seen some or the other friends who had a fracture, that white color POP cast or plaster of Paris cast they had on their hands. So there an X-ray will be taken, an X-ray image will be taken. So that can detect an X-ray, that can detect a fracture, and even genetic information like Indians look certain way, Europeans look certain way, Americans look certain way. So all these few people will get cold and they will get better in 2 or 3 days. Few people get cold and they'll not get better even in 5 or 7 days. So all these sorts of genetic information, X-ray images and blood tests are being fed to these AI models, and some of these models are going to tell you with certain extent of uh, good predictions, like what could be the probable diagnosis, what could be the probable treatment options, what is the prognosis. Right now we are not there at that level wherein diagnosis is 100% true, treatment options are 100% true, and even prognosis is 100% true. It is slowly improving upon year on year. Maybe 5 years down the lane we might have some model which is performing in a better way. So coming to the X-rays, what I have told you, there are certain other investigations called MRI, magnetic resonance imaging is the full form, and there is something called as CT or computed tomography. You might have seen some of these boards being written on the uh, some of the hospitals and these areas or laboratories wherein these investigations are being done. So these image data is also being fed into uh, this artificial intelligence model. During COVID time, we have also tried our hand using X-ray classification for COVID, like whether the person is having COVID or not. Using an artificial intelligence model, we have collected some 100 images of COVID X-rays and 100 images of normal X-rays and 100 images of bacterial pneumonia and tried to classify it. And the other possibility, an exciting possibility in healthcare, what these robots can do. Uh, so there is something called as paraplegia or quadriplegia. What does that mean is your brain is essentially cut off from your upper limbs and lower limbs. And that particular person who is suffering from these conditions, even though he or she wants to move his or her leg, they will not be able to move the legs or move the hand, and they will be bedridden. So there is this company called as Neural Link. So this is the device which can be implanted into the brain itself directly, and this is the robot which they have developed to place this device. You can see here small wires which can be placed inside the brain. So how do they do that? uh, these are thinner than your hair what is there on your head, and these can be placed in the brain. Here you can see an image on the right side, which is this red colored thing. That light pinkish area and the dark reddish area is, this is a blood vessel and this is the brain tissue. So they have trained the model in identifying where a blood vessel is there and where there is no blood vessel, and they will put one wire after the other into the cortex itself, and that model can predict. So what they have done, they have anything in healthcare, initially it will be tested in a simulation. Just like how you play games, there are certain simulations, they will test it there. After that they will test it on animals, and after that, once the animals are found to be safe and there are no side effects of it, then the approval for limited human testing will happen. So this is the general trend in healthcare research. So here in this pig, if you see, you are not seeing any huge device here. So that neural link device has been placed inside the brain of this pig, and as it is going about his daily routine, you can see these points, some graphs here. So this device which has been placed inside the brain is communicating in real time, and it is generating the electroencephalogram. Before these technologies have come in, it used to be a set of electrodes connected with multiple wires, and the patient should be close to that machine, and he cannot, or he or she cannot move from that place and has to stand still to capture this mechanism. So with AI based, with artificial intelligence based things, a wireless device, a micrometer thick wires without injuring the blood vessels, and placing the device and collecting the data. So this was possible. So now let's come to the beauty of it, or the good possibilities of it. So that brain activity has been read here, and so in artificial intelligence there is some terminology called as actual and predicted. We sometimes call this actual as ground truth. Matlab, like, what is the actual truth and what is the model telling me? So whatever model tells me, it is called as prediction of the model. I know what is the actual truth. So let's understand that. So in this example, the pig is walking on a treadmill. So all these triangles, what you see here, it is predicting that where the shoulder of the pig is. So here it is saying that it is there here, and actual may it is there here. So based on the brain activity, the model is trying to locate the positions and how the joints are. So what is the use of it? As I told you previously, a quadriplegic person who is not able to send the information from his brain to his upper limbs, hands and feet. Now the model understands, after reading his or her brain activity, that this person wants to grab hold of that glass of water and wants to drink that water. So now you create an exoskeleton or a mechanized robotic arm, like you have seen in your Iron Man suits and Iron Man movies. So that sort of mechanic prosthesis, like it is an aid for a patient. So those things are already available. Mechanical prostheses are already available. What we don't have is transmitting information to the prosthesis, how much it should lift up the arm, where it should position the arm or the hand of the person. Now with this technology in healthcare, it is going to be revolutionary. If a person who is not able to use the limbs can use them effectively. So this is not a very far away dream. It might happen in our lifetime, and they have almost moved from pigs to monkeys in the last 1 month itself. So let me show you some of the work what we have done in our university. So the left side, this is a classification model wherein we have trained the model using something positive and negative. So what is that something which you see here as brown material is a fungus which grows specifically in people during COVID times, or people who doesn't have their immune system to fight with. So in such people, it is going to be a problem. And during COVID time, we tried to do this identification by the model. And in the data set, what we have created, just like how I have shown you, Anil smiling, Anil not smiling, we have captured the images and we have put those things for training. And the model has performed better. Similarly, we have done that for malaria detection. So in a particular, I wanted to show you all these things in real time, but because of some technical difficulty in the Mac, we have trained it. I'm not able to show that to you. And so these are the screenshots of that image. As a backup, I have retained some of the screenshots here. So this is the malarial parasite, what is seen here, and the model is showing it as positive. So if the model makes a mistake, for example, you are seeing the malarial parasite here, and the model makes a mistake, we can train the model again, as you have done the mistake, by clicking the red button here, and it will train itself. So how these images are taken, we have taken the blood sample from the patient and we have prepared a smear called as peripheral smear, and then we will see it under the microscope. That microscope has a camera which is attached to the computer having this model. So that's how the model predicts this. And here in the bottom row, we are seeing acid-fast bacilli. As I have told you earlier, tuberculosis is caused by this Mycobacterium tuberculosis. We call them as acid-fast bacilli. It is one of the acid-fast bacilli. And we have trained our models to identify these things in the sputum smears. So similarly, we are also working on breast, whether carcinoma is present or not, or for our undergraduate students, to aid them, we are creating a mobile application wherein it will tell them what are all the blood cells that are available. So here we have trained, there are certain blood cells. We call them as white blood cells. Under that white blood cells, again, there are multiple divisions. So just like our protection forces in the country, there are military, there are police, there are normal CRPF. Similarly, here in your blood also, you will have some cells called as neutrophils, monocytes, lymphocytes, and eosinophils. Some of you might be knowing these things already. And we have also taken CT images of the eye, and we have trained the model to identify the multiple diseases. For example, there is certain thing called as choroidal neovascularization. New blood vessels are formed in the eye, and there is diabetes related macular diseases and even normal. So we have trained the model on this data, and it tries to predict the next time onwards. Like we have used almost 12,000 images in this particular case. So if I get 12,075 image, the model will try to predict and will try to tell me whether it is normal or whether it fits into any of these diseases. So even in medical diagnostics, it is painful to give a blood sample. Injection is bad, right? We don't want that. We want something like a CT scan or an MRI where it is not painful, and we'll try to diagnose that. So similarly, we are also trying, and many of the researchers worldwide are also trying to avoid pricking for hemoglobin. So this is hemoglobin is something which is there in you, which is something helps in transmitting oxygen from one place to the lungs to the organs where the oxygen is being used, and waste materials are being transmitted back in the blood. So this hemoglobin is essential for us, and we estimate this is one of the most common investigation what we do in the patients. So we are trying to estimate it without pricking the patient. So that is called as non-contact method of measurement. So I'm sorry, I am not able to share this particular model, and everything appears very serious, and I don't know how much you people have picked up on the things, or am I boring? I'm not sure, but I think this might be interesting for you people. Like if there are any artists among you, it will be very much interesting. So here on the top, what we are seeing is a liver cell. Liver cells, like liver tissue, and these are the nucleus. A cell has a nucleus and cytoplasm, and they are arranged in a particular way, and there is a pattern to that. So what we have done, we have converted using AI. There is a process called as neural style transfer, and it can convert this particular image like this based on the input photographs or images I give to the system. So these are called as AI generated art. We have given it the name AI path art. So how it happens? So this is your original photograph, what you have taken in your mobile, for example, and this is a painting which is your favorite painting. So if you want to transfer this painting style, how the artist has painted this, how the brush strokes are there, these things, these color patterns can be transferred to this image in your mobile phone, and that gets modified into this sort of image. So these things are being used for even video classification. So AI is not just in healthcare, and not just robots, and not just your sound classification models. It is there almost anything you train the artificial intelligence model with good number of data and a decent code, which helps you in making these things possible. So whatever examples I have shown you, all these things are called as no code AI. I am a doctor, I am not very good at coding, and some of you might be thinking that like it might be complicated, how can I do? As I have shown you, the transfer learning models, all these things can be done without any code, and you can do it on your own also. These are some of the examples. So this is a smear of blood, a bone marrow smear, and that also gets converted like this. And that one single message, one single image, we can create multiple images out of it. So these are the questions I have given you people, and I got to know from the previous sessions that you people cannot interact right now, and you will be sending the queries over email. So I am more interested to see what you will be telling, like, will you be comfortable seeking medical advice from an artificial intelligence based robot doctor? So because you are the next generation, I'll try to see what you people might tell. Before closing, I wanted to show how far in actual medicine artificial intelligence impact has come. So this cluster of vertical colorful things what you are seeing, these are some computer servers which are there in IBM. So this is a big company, again they have created this. It is called as Watson. They have named this artificial intelligence model, which is an interactive model. Like you can talk with it like you talk with a person, and it responds back to you. And you might have seen some of the AI robots as well. I didn't touch upon those things, but this is very interesting for a healthcare professional like me. So this model, they have trained the entire research data available, and now the project has been started in 2006. It was in R&D phase. Then they have brought it to a game level within 5 years. So this is the Jeopardy game, wherein a general knowledge question will be asked. For example, in this question, it has been asked as who is Bram Stoker. So if you see the money that has been made for this particular game, so the AI Watson is winning, and it has won the competition between the two other human participants who are supposedly the best participants. So this was the story in 2011. So from 2006 start, within 5 years, it has uh, won the Jeopardy Grand Challenge. And after that, within 6 months, they have devised something called as Watson for Healthcare. They have come up with a commercial model wherein hospitals in America are asking questions after giving the data about the patient. You tell me what are all the treatment options other patients have gone through, and how my particular patient will be helped based on the treatment options I am planning. So these are my treatment options. You give me the probability which is best suited. This has been done from 2011. So in 2012, they have moved forward with financial services, and now they are merging things from financial services to legal services to hospital services, electricity grid management. So it is even going in security services. See the pace of development in a span of hardly 15-20 years. It has become a money generator. It is not something there in a computer system somewhere or there for fun sake in a mobile. So these are serious amounts of money, and they are being used across. So if everything goes as per plan, and I am saying again, if these things don't turn rogue on us, it is a good development for humanity as such. So if there are any questions, I'd be more than happy to take them over
Doctor,
over email or
yeah,
mail. You can send me over email.
yeah. Dr. Anil, truly it was an excellent presentation. That too,
Thank you,
a
sir.
doctor on AI, artificial intelligence. Your talk was like engineer delivering a talk on AI. It was such a excellent presentation. Indeed, from the basics, you came down to the applications of AI in medical field. It was an excellent talk, and you told wherever the application is being used, and also about the IBM applications, etc. I'm sure students will get a lot of take-home message from your talk. On behalf of KSTA and all the participants, we are very grateful to you. Truly, as I told in the beginning, you are a true role model for students to emulate, because as I told in the beginning, some people say if you are a biologist, you need not have to know about engineering. Engineers say you need not have to know about biology, and so forth. And truly, it was a great experience and wonderful presentation. And we would like to have such talks in future as well, because we want many students to pursue a science, multidisciplinary science, not only medicine or engineering. They should be able to understand what is going on in the field of medicine and engineering, and choose their own field based on the information they get. Once again, grateful to you, Doctor. Thank you very much. We have with us Dr. Kushal sir. Over to you, sir, for your comments. Sir, unmute.
Sir, you are not audible.
ಸರ್ ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿ ಸರ್.
So, no, sir, not. Please unmute, sir. In the meantime, any other comments or question? Sir, Dr. Anil, there's
sir.
a question. Can AI artificial intelligence be implemented to diagnose heart attack?
Yes, it is possible to do that. So heart attack, usually the patient perceives the pain, but before that, if we can a particular specific high risk group has to be identified, and then that data has to be fed, and who has got heart attack in the previous hospital visits. That data, once the model gets to train on, it can predict heart attack possibility, and it can even give a score. Once your weight increases, it can even predict like how high risk you are at getting a heart attack. It is possible.
Thank you. Anthony, any other question?
No, sir.
There is a comment. It was an awesome and innovative talk, role model for all PU students. It is a just comment from Dr. Netravati. She is a PU teacher.
Thanks a lot, madam. Thanks for your kind words. Thanks for the opportunity, sir. I would like to thank my institute as well.
Thanks, Doctor. We have with us Dr. Vijayalakshmi Patil, madam. Then Dr. Kulkarni, Dr. Satish, Dr. Shilpa, Dr. Savitri, and Dr. Sureka, and many students, and also PU lecturers are there. Dr. Netravati is there with us. Thank you all. If you have any questions,
I'd like to disconnect.
you may please ask Dr. Anil. Now, Kushal Das sir is joining again. Just a moment.
Am I audible?
Yeah,
Sir.
yeah, you are audible now.
Yeah, I have some combination problem with the video and audio. Both are not working together. Yeah, that's fine. Thank you very much, Dr. Ramesh, and thank you, Dr. Anil, for excellent talk. And I think Dr. Ramesh has briefly and narrated nicely the entire sum up of your talk as such. And no words to say that it is a very interesting domain and very advanced domain of science itself. Forget about the medical science. Medical science is derived from the physics, chemistry, and mathematics. And then biologist comes, then biology derives further to medical sciences. So artificial intelligence actually too much of latest. And specifically for medical persons, it is, I think, that far away as compared to the physics and mathematics and chemistry, the pure science branches. So there will be some difficulty, no doubt about among the doctors. But I personally feel that persons like you and youngster who were doctor by profession, but simultaneously technologically so sound must be, as Dr. Ramesh has clearly mentioned about you as a role model, that to be the role model of the future science. I feel the young scientists and young, all the students and other young faculty and all senior faculty, those who are here in medical or other domain, they must realize that artificial intelligence is a part of life. Slowly it is becoming a part of life, and in future I think that many tasks will be solved in this regard. I have only one thing to bother about. I think that many of us, like even Dr. Ramesh, may also bother that artificial intelligence, do you think that it will replace the medical ethics as such? Because the data collections of a patient without their knowledge and making it to using for artificial intelligence, do you really think that it is not violation of the ethics? So it is not
It,
part of the research, but as a medical ethics, as a doctor's ethics, sharing of the data, even the hospital, corporate hospital or teaching hospital like us, is it really sound in that aspect? How that part will be resolved? How ethically it challenge can be actually overcome? Over to you, Anil.
sir. I agree with you, sir, on that. It is a right now. It is a gray area. Even though we say anonymized data, patient identification details have been taken off from the CT scans or slides and images and all these things, there are certain things going on wherein, for example, Google has employed some 300 odd people. Every 3 months, they are going to go to their centers and they are going to give blood samples, and their weight and wearables are being used and they are being tracked. And right now, there is so much of data where they say that Google and these Microsoft things know more about us than we know about us. And even they can predict when we are going to make a purchase and timely things they are showing as advertisements to us. So with this level of corporate interest involved, it is difficult to maintain the ethics. So that's why regulation is very much needed. And sadly, these part of technologies are poorly understood by even the medical professionals like us. And so there is a gray area, and ethics, as you have raised, it is an important point, and it has to be tackled with heavy-handed regulation rather than, even though it might kill some amount of innovation, that heavy-handed regulation is needed in this particular domain.
Thank you.
Sir, okay.
Thank you, Dr. Anil. And specifically, I'm concerned with the doctors nowadays connecting to the specialty, super specialty, and other discipline through WhatsApp. So, and we do not know about the integrity of the WhatsApp individually, how it much of impact. Even sometimes this information report is shared in a doctor's group. So how, without the knowledge of the patient, and this data can be shared, or even this may be used tomorrow as a biological weapon, because a country through the Google or through their own satellite, if they collect the information of a specific another country, maybe the enemy country or all, and collect the information from there, the raw data of their health status of their important peoples, or even the common people in a common area, they can use the biological war in that way, in a very simple way. COVID is a classic example that we could not do anything when COVID entered.
Yeah, you are right, sir. But as long as it is for public good, it should not be much of a problem. Ethics, of course,
I
is there.
hope that there should be a good regulatory movement that, as Dr. Anil has mentioned, a regulatory body, it is from the institution or hospitals to government level, each of the nation and then global, that should be maintained very strictly, specifically using the artificial intelligence. No doubt, it will replace many of the critical angle to diagnose some of the serious issues, but definitely it will help us. Thank you, Dr. Anil, once again for
Thank you, sir.
excellent presentation and excellent answers.
Thank you very much, sir. Thank you, Dr. Anil. Once again, thank you very much.
Pleasure, sir. Pleasure is mine.
I must thank Dr. Kushal Das, sir, for identifying excellent resource experts for us from North Karnataka. Especially when we think of webinars or seminars, we only concentrate on Bangalore or nearby places. Sir has been helping us in identifying right resource persons for talks. On behalf of KSTA, we are very grateful to you, sir, Kushal Das, sir. Thank you very much.
Thank you very much. Thank you. No, I'm also thankful to KSTA, its chairman, CEO, you, yourself, and all the executive members, and everybody who are connected to KSTA and the government of Karnataka as such. Thank you, sir.
I also thank all the doctors who have joined for this talk and also participants being with us for this wonderful talk. On behalf of KSTA, once again, thank you very much. All the best. Grateful.
Thank you.